night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, it's too late to try to go contain it. A generation fueled by creation. We live lives on a small screen nation. We control the airwaves, no negotiation. I refuse to think we need saving. Something good will come from creation. And when we think that the world is too anxious, we'll adapt, evolve, survive, and save it. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong.
Nobody's coming to save you. Get up. Be your own hero.
Good evening, ladies and gentlemen, and welcome to Sovereign Soul Unchained Mind. This is take 2. I thought I was live. I went through the intro and everything, and I came on, and my little handler back here, Something Wong, is indicating, he told me, he said, you're not live, and I said, oh shit, sorry, Some. And so we just went ahead and did it again, you know, and said, fuck it, we'll do it live, right? So it's been one of those days. All right. But anyway, we're coming to you live 250 miles above your imagination in this IT nightmare we call the International Fake Station, up here chasing each other with gorilla suits and playing guitar and doing somersaults and all kinds of important science that is definitely worth the millions of dollars a day that it's costing us to do this. We're definitely not laundering money for other purposes at all. So don't even think that, because if you do, then you are a tinfoil conspiracy theorist. Okay. All right. So now that we've got that out of the way, I was told to say that by my handler back here, Something Wong. Yeah. I ran into him at the Chinese food place down here, and never mind. It's a long story. Anyway, here we go. So tonight, I thought we'd give it time to get into it a little bit. And I had already watched a little portion of the first portion of this live debate on modern day debates between Nathan, or Pitchlumin, I believe as he goes by. And I still can't get straight why I can't find his channel or why it's gone. But anyway, he went up against MCToon. So I figured we'd check that out and tolerate Toon for about as long as we possibly can. And who knows what the fuck we'll get into. But I did see that there were some good points being brought up. You'll notice at the very first part of this, Nathan had a PowerPoint presentation, but the moderator brought up his own screen of some kind and blocked up most of it and shit. I noticed he'd fixed his technographical difficultations. He got those all worked out prior to Toon's presentation, but that's okay. It gets into it. A little dry in the opening, but we'll get to it. Let's see what's happening on here. Let's see who's all here first. Holy crap. You know, we got all these people, got 52 people in here. You all be sure you hit that like button, man. be sure you hit that like button, share it out, subscribe. Make sure you're subbed over to my backup channel as well. That would be handy. But I got Jake in here. I see Kevin Barber's here with us tonight. Got Push Button 62, Chicago Cubby Bear. I'll tell you a little joke about the three bears here pretty soon. You got Boston Guy 51, Mr. Super Sidewinder, November. Okay. His daughter Barbara. Are you Owen Benjamin guy, or are you, what's happening? I know there's a lot of controversy regarding people with these bears, or maybe you're not even know what those are. I don't know. I'm just assuming by your name. We got Dylan Heron. Either way, you're welcome here. It doesn't matter. Let's see. Who else do I see? Mojo. What's happening, my man? He's over here on the East Coast. Dylan Heron's with us. Earl Lee. Better than late, I would imagine. Let's see. Awesome Town Matt came in here. He popped in. Logical Observations. One More Quarter. Day Trooper. Boy, all these people popping in here before it even starts up. Awesome Town Matt. Thank God can't watch MDVD without Dave's commentary. Hope everybody's doing well. He says, yes, we are. So we'll get into that, and we'll see where that takes us. If I missed anybody, I apologize. I'll probably see something come up. Bogan's here. He says, hey, everyone. Pop into Modern Day Debate and vote on the poll so Flat wins the vote. Yes, there is a poll over there. And that poll is, let's see where it's at right now. Flat's only at 32%. A bag of bread is at 18%, though. So, and then you've got 50% for a globe. But that's still, that's still big. That's still pretty big. So if you get a chance, we're going to go on over there. I think I've put the link in the description to the video. If not, I'll do it in the chat here. You can pop over and vote in it real quick, and I'll wait for you. We'll just wait. We're just going to wait so y'all can pop over there, vote into the thing, and then come back. No, it's all right. We'll keep going. I think I got Malcolm Sheen. I am so sorry, man. I am really so sorry. Everybody, Malcolm Sheen is here. Don, good to see everybody. All right. So let's see if we can get that number up a little bit over there on the poll. Let's see. I did put it in the link in the chat, and it's also in the description. Just pop over there for a second. Vote in the poll. Let me bring this thing up and see where we go from here. I'm thinking, though, watch what happens. And I'm thinking that, after this amount of time of using this OBS software, that Ryan should have a little bit better of a grip on how to do things like screen share and things like that. So it's starting to get to the point where I'm starting to wonder if it's accidental or not. That's where I'm at. So this is right as the little music and shit just stopped. MCToon looking the part. Yes, McLoon looking the part. Absolutely. Absolutely. Seems quite composed since his meltdown the last time we observed this creature. And yeah, I have to wonder too about some people that are running in there and trying to defend him and shit too. Some real lunatic people, But anyway, it is what it is. I didn't say one thing one way or the other. I have my own suspicions, but in the court of public opinion, the reaction was not taken favorably toward MCToon. Anyway, let's get on with this and see what they're doing. 33 likes now. Illuminati confirmed. Absolutely.
Welcome to Modern Day Debate, everybody. Tonight we're going to be debating. We have Nathan Pitchlumin versus MCToon. It's going to be Flat Earth versus Globe Earth. And the first 12 minutes, we've decided to do 12-minute openings between the two speakers. First 12 minutes is for you, Pitchlumin, sorry. I'm used to calling you Nathan. So 12 minutes for you. Go ahead.
All right. If I could please share my screen here.
Sure.
See, I think this is a clever thing too, because this motherfucker always got earphones in. Always. Now, I've figured out a way here that I don't require headphones and I don't get feedback. I'm playing other media. I watch and listen to all the things that are happening. I know what will share and what doesn't share. Okay. And we're not having any feedback issues or anything. Nothing in this ear, nothing in this ear, no big clunky headphones or anything else like that. So you can't tell me that after this amount of time, that's the best he can do is have to have these earplugs. That's an excuse. That's so he can have people talking into his ear. And you know he fucking does. You know he does. These people are completely dishonest. They really are. And of course, we're going to get the circle of despair.
Thing.
Share. Do you see a do you see a PowerPoint here?
Yep, we're looking at your PowerPoint now.
Okay, awesome. So this is the cosmological contention. This is globe versus flat. So which is it? The Earth could be flat, globular, or neither, because
Oh, you son of a bitches.
the flat and globe claims are mutually exclusive. Empirical science can determine falsification of at least one of these models. We should consider where the evidence most simply, without contradiction, supports which model, based on the preponderance of data collected from various fields, measures, observations, detections, and claims of logical reasoning to explain phenomenon in the model, again, without contradiction. When considering an alternative view in good faith, please consider trying to omit all of the current model's claims and take.
So there's this, and watch over here in the chat. I'm going to turn the, well, I guess it's up as high as it'll go. Let's see if I can get it to 1080. Well, it's 760. Let's see if 1080 makes it any better. Can we read the chat or is it too much? Let's see. Thinking. Yeah, you can read the chat a little better. So what you're going to notice over here in this is that you'll see people start telling him, hey, dude, Ryan, you know, the moderator guy, nobody's being able to see the screen. Because at this point in time, instead of actually paying attention to the fucking debate and shit and moderating it, he's doing other things. He's trying to screen share this with somebody else, this other fucking thing right here. Or at least that's what he's saying. And I'm like, that's bullshit, man. After this amount of time, I'd make him go. If I found out that had happened on mine, I'd say, well, we're going to have to go back. Give me my time back because you just fucked it all up. You fucked up my opening, man.
Take what the proposing model has to offer for this alternative contending viewpoint. We have a body of data we can draw from observations to body senses, experiments with variables to maths and predictions. With cosmology, Earth's physical shape is the primary determiner. All other phenomena are explained off of the ground, which is very measurable, so favorable for figuring. Sky data is secondary, upon the ground or around the sky, and how objects interact over the surface is tertiary, due to happening within the cosmology and not directly addressing cosmomorphology. Let us take a look at samplings from each of these levels of determinants: geomorphology, sky, objects. And this is just something even to, I'm sure my interlocutor here would agree, and people in this community of cosmology discussion, terms like FE, what that stands for, heavily censored. So maybe we could use a term like geomorphology or something to hopefully get the word out there more to spread it and get around the algorithms because they are quite censoring to this topic. So we'll discuss these three. Geomorphology, when we first look out into topography of the Earth, observe what the observed world shows us. We do make observations that are planar, more suited to planar, and observations readily explained by a globe. That itself is a gnarly feat of nature. We observe events at times under natural available conditions that objects on the surface of the water. Hold on one sec, I got this screen in the way here. Oh wait, I can minimize it. My bad.
Did you see all those? It's like, dude, we are seeing your screen, people are saying, and it's like, dude never pays any attention to it. And it's like, dude, come on, man. He's already gone through like 2.5 minutes of you doing this and playing in your chat. You're not paying any fucking attention to what's being said.
There we go. Let's see. When we first look into our topography of the Earth, observe what empirically observed the world shows us. We do make observations that are more suited to planar, and observations readily explained by a globe. That itself is quite gnarly. We observe events at times under natural available conditions that reveal objects upon the surface of water to inherently impair planar. That would be the
Oh,
thing.
just a sec. I don't think they see Nathan's.
Yeah, they did not see
Yeah.
it because
No, they didn't. Nobody saw it. Duh, you were playing in the chat. What the hell here? Go ahead. Play.
I did a window
There.
share. My apologies, and I looked at I've looked at the live chat. I see you guys hanging out. So sorry, Nathan. Let's continue on because I have a window share going on so everybody can see us. So sorry about that,
Okay.
guys.
Okay, and I don't think I had. Okay, so I should be. I'm good to keep going.
Yeah, you're good.
Okay. So the top left here, we see things that appear inherently planar to us. Likewise,
I'm going to drop it back down. So it
we
doesn't
observe
give
at
us this
times
crap.
under naturally available conditions that real objects being occulted from the bottom up, inherently appearing to look like spherical curvature, which I have down here with the boat and the skyline. This alone would be impressive for either model to make claims of cause, explain and account for both observations without contradiction, as the
Don't these people like look at that skyline? Don't you realize that if there's curvature in that direction forward of you, there should be that same amount of curvature in all directions, right? You should see that kind of, and so theoretically, if you were to draw a center line up the middle of each one of those buildings, plumb to the horizon, that would mean that they should all like be spreading away from one another. And they wouldn't be. I mean, it's not indication of of convexity in a spherical sense. It's more in a cylindrical sense, which is, of course, ridiculous, even worse. All right, come on, you damn thing.
Observations themselves appear conflicted. Consider the water observations are the most physically bearing for shape, as both sides claim a characteristic of water to be that it seeks level, and water does not have topography, gradual slope, hills, jaggedness, etc. Demo and explanations, control variables, and recreations using them.
See, this is the thing about fluids, and this incorporates gases and liquids, okay? That they're not molecularly bonded really to one another, especially like with gases or water. It's fluid. In other words, it changes. It can change at all times, and of course it's going to seek its level, but you can make it do all kinds of different things. It's going to conform to whatever container that it's in. Every time it's going to conform to that. But then and this is what people just don't understand. It's never going to form a shape on its own. It can't. It will not.
Granting both sides their ability to recreate the apparent observation, we must see if there's a way to recreate the contrary observation with conditions we would expect nature to provide, aka real-world experiences. So on the left here, you have apparent spherical recreation on a flat surface. This would be a simulation of bottom-up disappearance. And so as you can see here, you have low objects, taller objects, medium objects, and as there's a temperature inversion, you get a bottom-up disappearing, even only leaving the tallest structures. The apparent planar recreation on a curved surface, the globe so far has failed to recreate a planar observation on a known curved surface using any claimed variables and demo the variable's ability to create the contrary natural observation. The globe has yet to substantiate the apparent planar surface seen in reality. As far as the claim to motion goes, because it's not just shape but also motion, the globe does claim to be mathematically and philosophically equal to the flat earth claim of stillness, so the lack of motion and sensation of motionlessness are equal here. As to how of accelerative motion is not being felt or detected, that we can be addressed in the tertiary realm of discussion dealing with forces and attributes that reality exists in.
See, this is why I don't like using a written. I mean, by all means, if you have notes or something like that, that's one thing. But I don't like having a written presentation like that. You know, I'd rather it just flow. I don't know. That's just me. And I think it's more captivating to the audience as well. I mean, I kind of do show notes, you know, and if I can find them or whatever around here, but everything I'm just like off the cuff. It's in constant motion. So I'm just going, hey, you know, and responding to where I need to be. I mean, I can lay out a point cohesively without having to read something, you know. I mean, it sounds to me, in my thing, I would be like, yeah, somebody else wrote that for you. You don't even know what you're talking. I mean, that would be a good way to refute it or whatever if you wanted to go down that avenue. But I would prefer it come from my own words. It's like I was talking to some jackass on Facebook, and he says, would you like me to link you to something so that you can understand it better? And I says, no, I want you to explain it to me in your own words. This shouldn't be a problem for you since you understand it so well. Okay, so I already knew that part of their script was give them this link or give them that link. No, I don't want to. I'm not clicking no links. I want you to explain in your own words. I have time. Go ahead. I have time. If you think I have the time to peer over your article that you probably never read, or your link that you've probably never really watched critically, no, you got time. You have the time to be able to explain it to me. So if you truly understand it, you shouldn't have a problem. But anyway, he's doing all right. I just don't like the written reading an opener, you know. I would kind of use it as a go by, but it just doesn't sound natural.
Motions or motionlessness, observations, claim measures of the sky. The diametric opposition of helio and geocentered claims being 180 degrees opposite means reality can exclude one or the other through empirical demonstration. The planar Earth, currently having primary support, claims that the stars move, are approximately equidistant, and can be used for navigation in time due to having cycles. The globe claims an apparent still sky moving due to Earth rotation, different distances to different stars, and have the properties attributed to cyclical behaviors. This is just a beautiful picture of our night sky. I know people zoom in on stars. I prefer this kind of open sky. It's just beautiful. Extrapolations from the abode of the above.
The first time I ever saw the Milky Way, it freaked me out. I had never seen that many stars at one time at night, right? And I was like, man, this is so clear out here. As soon as that cloud goes by, I'll be able to see the stars behind that too. And then I realized it wasn't a cloud. It was actually the Milky Way. I was like, holy shit. It was pretty cool.
Due to relativity claiming equality overlapping with the motion slide, direct determining of which is happening, Earth or sky moving while the other is still, is not discernible. AKA the relativity trains where one is moving and the other is still, or the one is still and you are not moving, or are moving. The only motion we measure is explainable by both without contradiction, as we measure 15 degrees per hour. Planar Earth claims ether vortex, while the globe claims rotation as an absolute motion, while all other claimed globe motions are carried in space-time fabric that has the discernibility of constant linear motion, hence the trance. The display of distance. Both models clash with distance being roughly equal, plane, or variance, globe, and can again be empirically filtered based on natural laws. The specific version of parallax used here is able to discern betwixt the two claims. Optical parallax is a phenomena that we observe when we move our observer and compare motions of close and far distances to the observer. We observe close objects boogie through the field of view fast in scale and slowness relative to the distance back, as objects farthest in the background appear to move slow. Think phone poles, tree lines behind them, and mountains out afar as you travel along the road. The poles move quickly past you at the same rate, which is key, and the trees further back move a little slower, and the distant mountains appear to hardly move at all compared to how many phone poles you have passed. Time-lapse observation. When we see a time-lapse of the sky pictured at the right, we look at the sky, we see the stars move at the same rate. This is comparable to the uniform motion of stars, implying the same distance from the observer to the stars. This is similar to the phone poles that pass at the same rate as one travels along the distance. As we move at 15 degrees, we see in an angular field of view. We do not see more distant stars span less angular field while we turn about. This empirically shows that stars are similar in distance, otherwise they would conform to observational parallax. To cover cycles on the slide, navigation techniques and cycle configuration have been accomplished by both cosmologies. Both people can navigate and have cycle prediction. And just as a side note, if anyone is appealing to Newtonian, the lack of a shift in all the stars by 1 degree per night is not apparent, showing no orbit around the sun, because there's no 1 degree shift as we move 1 degree further along in the sun of our orbit. So object kinematics,
Just
the
stepping
claim
in
of
there,
abs-
Nathan.
So drunk several. Yeah, this is Nathan Pitchlumin going up against MCToon on modern day debates. So this is, you just caught us with their openings. We're just about done with Pitchlumin's opening, and it's going to be getting into MCToon's opening.
And just to let you know, you're past your 6-minute mark. So
okay, all right,
Go.
thank you.
Just
The claim of an absolute motion to a rotating globe means we can all collect data to see if rotational forces are imparted on objects as they leave Earth. The Earth is rotating, so motion is angular, therefore acceleration, and acceleration is not only felt, but observed and measured as well, needing only the ever-present Earth frame to base the motion atop. We can intake military documents, accomplishments, industry lingo, light precision measurements, interferometry, and our senses determine if something like centrifugal force is caused by the rotation of a sphere Earth. The preponderance of evidence, so this is angular acceleration. This is a NASA document showing how they use a flat non-rotating Earth. This is a Foucault's pendulum that has not moved throughout the day. This is actually down here in the bottom left is an email from someone who shot the world's longest target, 4.4 miles. They said they did not take Coriolis into account. This is the Michelson-Morley result, and then this is centrifugal force, and then the tomatoes I'll get to with the centrifugal force. So geocentric explanations. The planet Earth needs to be accurately represented as possible to see if it offers an explanation of the worldview, meaning seasons, time zones, sunrises and sets, light patterns, circumnavigation and flights, images of globe, observed forces all need to be explained cohesively. The Earth is not a disk in space accelerating upward, having waterfall edging. Using a basic model, while it's not specifically to scale, can help conceptualize a maybe less thought of idea like zetetic astronomy. The sun and moon do not go under the Earth, they remain above. So all these are misrepresentations. And then I think here, like this is a star up close, which is still really cool, but I like the sky. But then now the UN flag map, and then the Gleason map, and then this is just something to help get an idea of how things might work. Natural workings of the planet Earth, several claims, demos, examples, and explanations. Seasons are only are explained by the sun moving between the tropic circles, Cancer and Capricorn. These are only locations that the sun can appear overhead at zenith, 90 degrees perpendicular. There are more time zones in the southern hemisphere than in the north, with the equator having 24 to match the 1-hour distance of sun travel in a day. There are some 30 time zones plus time zones in the south. Tropic circles, close small circles in the summer, distant large circles in the winter, a less direct, more distant sun passing by faster, so less exposure to light throughout the day, all cooling for a winter time. This matches the solar analemma. A globe would provide equal loops to the analemma so long as the claim of the Earth orbit is planar and that we're not on ecliptic. I think.
Oh, I was muted. Sorry about that. I was just told that dude about his tomatoes really being good. Drunk several. You haven't had our space tomatoes, bro. We grow them upside down. They're cosmically fucking delicious, man. You wouldn't even believe it. It's insane. And we fertilize it from the vacuum toilet, so it makes them extra good.
It's just the Earth that's tilted. But you have the analemma here to match the smaller circles in the north, and then the larger circles as it loops on the outside.
Oh, I see what you did there.
Sunrise and set have been shown on a flat surface using atmospheric variables like magnification and temperature variance to show how sun can appear to rise and set while keeping the same size and shape. So these are actually globe scientists who say that the atmosphere acts like a lens. This was during the Chicago skyline. Chicago City being viewed from Michigan, which defies the curvature rate of globe. And then this here shows.
No, it doesn't. Shut up.
Using lensing that you can get the sun at rise and then have it.
God bless America. What are we
set further back here, and it will still appear the same size. This is just something talking about refraction here. Sun casting light. Light can only travel so far from the source of emission, attenuation of light, and the light patterning of a source like time and day, it's supposed to be time and date, has been recreated using a dome to simulate the firmament. So this is just a light pattern here, and then this is a very crude example, but it shows how you can get
30 seconds.
These lighting effects. Circumnavigation, we can circumnavigate, but anytime they try to go to the South Pole, they always bank. They never go straight through north, straight through to south, show a compass needle flip especially, and then go back to north. Flight routes, we have an emergency flight from Chicago to Dohan, and it stopped in Moscow, but despite closer emergency flight routes being more available. Images of Earth, you have Photoshop because it has to be. NASA using flat Earth. Sizes of the continents are extremely different. This is a water ball, and then we use.
We fertilize our tomatoes up here with a special fertilizer blend that we get from the vacuum toilet. This is why we have Don Pettit up here. He especially likes the chili mac freeze-dried food, and for some reason that going through Don Pettit into the vacuum toilet provides a really, really good fertilizer. It's called really good engineering. Yeah, that's it.
Flat maps, which are able to have a key and scale, and we use them to travel. And then duplication. And then this is the force, which am I out of time here?
Yeah, you did run out of time, unfortunately. So
okay, all right. Well, yeah, that is all. And then
there's just so goddamn much, man. God, Mexican apples. Hey, that makes sense. They are a fruit.
Nah, yeah, okay. Thank you very much. That was okay. Anyway, yeah, I'll stop there.
No worries. If there's anything you missed, I have no problem. If you want to bring it back up and come full circle, that's no problem. So let's just get back to our main screen here. So welcome everybody to Modern Day Debate. If it's your first time here, hit the like button.
Hang on a second here. I got to do something. I got to get this ready. Just a second. Just a second. All right, we got it.
Share this out in those spaces you like having these discussions. We're having a lot of fun over here. We're discussing flat Earth versus globe Earth. You just heard Nathan, and I'm sorry to anybody who was seeing my screen for a second there. I'm doing a window capture so that we can see the speakers while they're doing their presentations, because we had so many screen shares last debate. So over to you, MCToon. Thank you so much for being here.
All right. I'm sharing my screen.
Sharing.
All right. Settle down. Damn, this crowd don't like MCToon. Holy shit. Anyway, go ahead.
We're up and running.
All right. Well, my beginning will be quite similar. So how should we determine the shape of the Earth? In a series of lectures by Richard Feynman, he described the key to science. So I want to make sure that this audio comes through. Let me know.
And who the fuck made Richard Feynman the god of what science is or isn't anyway? Who did this? Fuck him.
Know if you're getting it, Brian.
First, we guess it.
Yep.
Then we that's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong.
There you go.
And that simple statement is the key to science.
Bah! There you go. Right? If it fails experiment, then it's not right. And now comes in what is a valid experiment, right?
To actually establish the shape of the Earth, it requires computing the consequences based on the hypothesized geometry, including applying the laws of physics. Ignore the laws of physics and you're not computing the consequences. Then you test these computations by comparing them to observations. And if the computations match, then you have evidence that your hypothesis is correct. Nothing is proven, but it supports your hypothesis. And if the observations don't match, then the hypothesis is wrong. It is falsified. But flat earthers fail to do these.
So in other words, if you postulate a globe of a specific size that turns out to be roughly 7.9 inches per mile squared of curvature in all directions, then these observations should match that, and there should be an actual physical horizon at a certain distance. But we see things for too far, and you can only carry the refraction idea to a certain amount. Okay. That you know, it's not going to lift up an entire skyline miles into the fucking air so that it looks like it's at hers, you know, because the Earth's constantly trying to trick you into thinking it's flat. This is what they say. The Earth is trying to constantly trick you into thinking it's flat, but it's in reality a globe because of some math that we created that doesn't match what we observe in reality. Right on.
These in two ways mainly. First is by getting the globe computations wrong. When you ignore confounding
LVA,
variables,
Paul, good
which
to
is
see you,
super
brother.
common, you're strawmanning the globe. And number two, by never providing computations for flat Earth. If you're unable to compute the consequences for flat Earth, you showed up at the horse race without a horse. You're not able to even begin doing science.
Sorry to cut you off, Mike. Can you give your mic a little more love? You're just coming in a little low.
A little more love. Oh, that is a cool way to
Okay,
say
I'll
that.
turn you up. Don't worry. Just carry on.
Oh, okay. All right. As a contrast to the standard flat Earth method, I'll use both globe and flat Earth
Arg.
to compute the consequences of each hypothesis and compare them.
I hate you, YouTube. You suck.
Observations.
Buttholes.
I'll use both flat and globe to predict the sunset time for my location today, February 20, 2024 in Minneapolis, Minnesota. To predict for the globe, I used NOAA's or NOAA's SalCalc website, which is on the screen there, to predict the sunrise for the sunset for the globe. NOAA provides a spreadsheet with the formulas for the calculations on that webpage there, if anybody wants to verify how the consequences were computed. So I calculated the sunset time for today, February 12th, from Minneapolis. The globe predicted sunset time is 5:47 p.m. And I was at a Thai restaurant in Richfield at 5:47 p.m. And there's the picture out the window. The sun was setting. So I personally observed it to set at 5:47 p.m.
Awesome. A post-diction was made because it's the same every fucking year, Mike.
Globe confirmed. The flat Earth, well, that's harder. I couldn't find any resources for predicting the sunset time using flat
And here he
Earth,
goes
so I
again.
computed the
God damn it. I wish
consequences
people
myself.
would call this bastard out on this shit once and for all. This use of Euclidean third-person perspective geometry to explain three-dimensional perspective. That's so dishonest. It really is.
To compute the sunset time for flat Earth, we need to determine when the sun will cross the horizon according to flat Earth. This is done by applying the laws of perspective. First, we need the elevation of the sun over flat Earth. Some flat earthers,
He has heard of it. However, he doesn't fucking he doesn't want to go there. He doesn't want to go there. He starts getting emotional.
give values for the height of the sun. Not very common, but some have. Samuel Rowbottom said less than 4,000 miles. Wilbur Voliva,
God bless America. I don't understand why this is happening.
Alexander Gleason, who popularized the most commonly cited flat Earth map, but it's just an azimuthal equidistant projection from the globe. Anyway, in his book, he claimed the elevation.
Before he goes any further, it's actually new standard map of the world on the projection of J.S. Christopher. Okay, based on the projection of J.S. Christopher. Which, of course, had to be approved by some Royal College of Maps or some shit.
Of the sun to be 1,725 nautical miles or 1985 statute miles. And Eric Dubé even gives a value himself.
Both the sun and moon figure to be only about 32 miles in diameter and approximately 3,000 miles away.
But there's some variation there. So I measured it myself on both equinoxes from 45 degrees north latitude, where I live in Minneapolis, hypothesizing flat Earth, and got 3,105 miles. Details of that on my website if you want to see. I'll start with this number. And if any flat earthers have a different value with a more rigorous method than mine, I will be glad to use it. But I have never been given one. Sometimes, I keep asking, but flat earthers rarely present any method, anything that's testable to determine the elevation of the sun or anything else over our own flat Earth. Why not, guys? Give it a shot. Just predict it. Get to work. Roll up your sleeves. Anyway, I did it for you. Once you have the height of the sun, you need the distance from the observer to the subsolar point on flat Earth. This would be easy to obtain from a real map. However, Gleason's map doesn't have a scale. There are no flat Earth maps with scales.
What the fuck? Yeah, that's the one I'm looking at on there. Okay. LVA, check it out, man. Put that link back in the chat. I gave you a wrench so it can be shared, bro.
But we do have this from Gleason's map. This is the thing that sometimes they call a scale. It's not a scale. You cannot take that and lay it on the map to determine distances. But the part I circled there states very clearly that there's 60 nautical miles to the degree, and that is definitely true for lines of latitude. I completely agree with it there. That is a fundamental part of celestial navigation. So I'll use that happily. But when we do that, then we can sort of shoehorn the latitude and longitude into being a polar coordinate system. I won't go over the details. It's some algebra, high school algebra. Then we can apply the polar distance formula to get the distance between any 2 points. Again, flat earthers, I'm computing the consequences of your claims. If you think this is wrong, provide the right method. I'm simply applying geometry to flat Earth's claims. The subsolar point of the sun is the position on the Earth directly below the sun. It's well known for any moment of the year. At 5:47 p.m. Central Time today, the subsolar point was 10.8 degrees south and 173.7 degrees east. Mm-hmm. This is the ocean north of New Zealand. And applying the polar distance formula, we get a distance of 7,788 miles for flat Earth. Now we can fill in the distances and apply perspective. 3,105 miles high for the sun and 7,788 miles across the surface. To apply perspective, we simply solve the triangle. Then
that doesn't give you perspective. That gives you a third-person perspective. That's third-person perspective. The dude is right here at the apex of this fucking angle. That's where the dude's at. Okay? You're looking at it. This is completely and also purposely out of scale, right? Completely out of scale. There is no way that this would even be that kind of a triangle. No fucking way.
Then get the angle of elevation for the sun. Right there. This is, when you solve the triangle, 21.7 degrees above the horizon. That's the flat Earth prediction for 5:47 p.m. today as what we should see from Minneapolis.
No.
But observations do not match because in reality, the sun was setting at that moment. Flat Earth falsified. Again, flat earthers, I'm simply applying geometry. If you think it's wrong, provide the right method. I don't want to hear it's wrong and then have nothing to.
Non-Euclidean, dumbass. You have hyperbolic vision. Okay? This is a third-person fucking perspective, woefully out of scale in order to give a deceiving visual. I'll give you that. You're looking at 7,788 miles right here in this steep of an angle. What the fuck? No, that's purposely fucking the flat earth didn't predict that at all, because you're using this Euclidean two-dimensional geometry. This guy's a dishonest fuck. This has been pointed out to him a million times, man.
Follow up with it. Show the right method. Do you think there's some sort of optical effect at play? Provide the empirical evidence for these effects and the method to compute the consequences, and I'll be happy to update my method.
How about you pull your head out of your ass, you lesbian school teacher, and check and see if maybe you got some little bit of perspective there, bud.
Catchphrases and word salad are not a substitute for computing the consequences of your claims. There you go.
All right. Well, you still had some time on the clock there, so we'll just put this back to our regular screen. We are going to put it
for later
into open discussion there. So if you just got here and you're just hanging out, once again, hit the like button. We're going to be doing a Q&A at the end of the debate. And you know what? For funsies, I'm going to pop a Q&A in there right now. So if you're hanging out in the live chat at Modern Day Debate, we'll put up the poll there and you can vote. And we're going to put it into open discussion. So over to you, Pitchlumin. And yeah, let's have fun.
Yeah, let's
Damn you. Damn you.
That's yeah. Thank you, Mike, for that. I Feynman with the keys to science, compare calculations. I guess real quick, Mike, could you clarify compute the consequences for me?
Compute the consequences would be in most instances mean doing some math. You would need to now it doesn't absolutely always have to be that, but
no, it doesn't, because math is not fucking reality. Math is only a description of what is observed. So whether or not you can put a mathematical formula to it, the observed effect is still the observed effect. Bingo. Pull your head out, quit fucking beating off over goddamn algebra books and shit, and look at reality. That's what I've got to say.
You can, for example, if you are hypothesizing that a benzene ring is, or a six carbons in benzene is in a ring shape. So computing the consequences of that would be some way of then,
like measuring bond angles.
Yeah,
of the ring, what the angles would be.
Yeah.
Okay.
So that would be, computing the consequences. But if the sun is hovering over flat Earth, then computing the consequences of that would be, well, at this time of day, what angle should the sun be at for this location? When should it set? What is its angular size to be? These are all computations that we can do.
First and foremost, what is the sun? And how do you know what it is in order to measure the damn thing? I mean, it may appear, and by mathematical, in some of these calculations, to be what they said, 32 miles in diameter, 3,000 miles away. I have no idea. I have no fucking idea. Right? I know it's not 93 million miles away. It doesn't behave like an object at that distance, especially with the size and everything else that they give us. So, I think that's probably one of the first and foremost things, because then that's going to require MCToon to be going, well, it's this ball of 836 miles in diameter and it's a 93 million. Okay, how do you fucking know that shit? And I don't want to hear about your theories. I want to see absolute fucking verifiable, observable proof. None of this fucking hypothesis bullshit, man. That gets old quick. That gets old really, really quick.
Based on physical objects and known laws of physics and geometry.
Okay. So if I
God damn this
thing. I may point out here, so in your diagrams it had shown
I'm gonna get rid of some shit
geometry, which I do agree.
Got too much shit going right now.
With that, the math is correct. If you measure the the height of your object and then the length of the shadow that it casts and the angle, you can calculate the height. I would like to point out as potentially some scrutiny to the how well that mathematics compares to reality as far as trying to apply it. So the claim of a flat Earth has an atmosphere which can have distortion, refraction, cause a shift in apparent position. There is also claimed to be a firmament, at least that I will claim a firmament above us. So it is a structure that is a different medium from the air, especially if the air is very thin up there and then it suddenly hits like a dense medium. And I'm actually not sure how far embedded into the firmament the sun might be. 3 feet or 50 feet or 100? Is it on the other side of the firmament and maybe the water up there is another medium change? So I think that those would, in the geometry you showed, I think you provided straight lines, which is accurate for geometry, but I think that those apparent distortions, the refraction to light would cause a bend of the light. So maybe those triangles are not necessarily ascribable to reality. Because I myself do not.
So how would, so then my question is then let's go through it. What's the correct way to do that then?
So I'm not sure because I don't know how to correctly try to measure the sun as far as its height. Unless like I can't think of anything. Taking a tape measure up to the firmament, even if we say we touch the top of a tape measure to the firmament and then dropped it all the way down to the ground with a really long tape measure, whatever that height is, if the sun is behind that glass casing, we can't put our measurement up into there and determine that physical tangible measuring itself. So I don't know of any way.
So he's kind of alluding to the idea of what is the sun. You know, we have to know its location. We have to know the medium that it's in. We have to actually know what it is. Is it actually a physical object? Is it just a point of energy? What is it that we're seeing? And anybody that tells me the sun never changes sizes, it changes apparent size all the fucking time. It's not nearly what it is in the summertime from here. Okay. It's the same thing with the moon. And of course you've got the lensing effect of the atmos. You know, the more moisture there is in the air, it's going to magnify. So there's, always looking for this one-step solution. And it's usually, there are several different factors involved that they don't account for.
Glass reflect radar.
Does glass?
It does. It's a trick question. Of course it does.
Okay.
So why, when we point radar up to the sky, does it not bounce and show up as something there at some reasonable elevation for what the firmament would be, unless we point it at the moon?
Unless it were to perhaps absorb it. And I don't know if you ever pointed radar at the sky and where the moon's not. I don't know.
We pointed at the moon, then we do get a bounce back.
No,
of
you
that
don't.
Radar, and the distance is a particular distance based on the amount of time that it takes.
Yeah,
everywhere else, we don't get that. Well, not everywhere.
That's bullshit. Nobody's got a fucking radar or a radio or any other goddamn thing that's going to send anything 236,000 miles. I'm sorry. That's 250,000 miles. No. It requires it. Listen, output is directly affected by the input. It just doesn't go on forever and then bounce back. What the fuck? Get out of here. 236,000 miles? No.
Where else? Because when we pointed at Venus, we get it back, or at the sun, we get. Anyway, if we
you don't get it back from
planet,
Venus. This motherfucker is lying through his fucking teeth. This kid ought to be jumping in here and saying, you do not have radar that can shoot that far. I'm sorry, baby. It's not going to happen. It doesn't happen.
Reflection. So why is the firmament, which you said is glass, not reflecting radar.
Yeah, glass. Maybe I should say, I might have misspoken there. I guess I could say like crystalline structure, or it's like a molten glass. I don't know the exact chemical makeup of
Things that would reflect radar.
No, some things absorb radar, MCToon, and you know that.
Well, if it's a chemical crystalline structure that we are not really too familiar with, it could penetrate that, and then it could hit objects like if the sun and moon and luminaries have some sort of reflective property.
See, MCToon's turned this around to what's it made out of. I don't fucking know what it's made out of. It has to exist. Otherwise, we would not have air pressure. Now, this is good. This would take him into the whole, I didn't let him, work me into that. I don't know what the fuck it's made out of. All I know is that in order to have gas pressure, air pressure, it must be contained. Only a contained volume of air can have pressure. That's all. Okay. So who gives a fuck what it's made out of? I don't know. Loosen the restrictions and let people go find out. Okay. Don't even get into that fucking argument. The bottom line is you're claiming that we have a gas pressure system without containment for some reason. This would, and your whole argument is gravity. You can't demonstrate a downward acceleration of air due to gravity. You can't. If you weigh air, you have to have a contained volume of that air to weigh. Okay? You can't just weigh air. Same thing with water.
How do we do science on that then? Because this is a lot of conjecture.
Yes.
Conjecture isn't science. How do we empirically verify these things? Has it been done?
Well, there have been things, I believe, like Dominic and fishbowl operations where there were things sent up into the air. And I believe that the Van Allen belts are something that is claimed to inhibit us getting out of low Earth orbit. And then you have like Bill Nye who says we're in a closed system. I think that there are things, the sky, I will.
Let me address a couple of things.
Yes.
The Operation Fishbowl and Dominic, those were not attempting to hit the firmament. They didn't go nearly as high as the claims of the firmament typically are, though the claims of how high the firmament are all over the place. They vary even more than the couple examples I gave of people's sloppy guesses at the height of the sun. I think there were tens of miles, not hundreds of miles up in those things. We can get through the Van Allen belts, and the quote that you're thinking of is specifically about the computer systems and navigation systems in the Artemis.
Drunk several says that all particles have weight. Correct, absolutely. And the only way to get these particles into a volume of appreciable weight is through containment, because the molecules, the particles are all moving around in different directions, and they will dissipate. Okay. And this can't be without containment. I'm sorry. Never.
Missions. So you need to certify any system that people ride in before people ride in it, that it won't have an error in it. So when you're that particular quote, which was a kind of a fluffy thing made for end users or popular consumption, not a scientific description of what was
to
going
promote
on.
Space travel.
Yeah, it's basically it has to be a contained volume. All right. And of course, I guess you could calculate that down to a specific particle weight. But there again, those particles are not bonded. And this is just basically how gas works. Those molecules are going all bumping around into the sides of the container and keep back and forth all over the place. And as soon as there's nothing there for them to bounce off of other than themselves, they'll start to escape the cluster, and they will start to dissipate until they've dissipated into the surrounding medium. It's just That's just how gas behaves, man.
Yeah, it taking that as a hard scientific statement isn't the
Oh, you son of a bitch.
right thing. That's not its intention. So the Van Allen belts, nobody has trouble getting through it. They're not that dangerous to people.
It depends on whether it's David Lee Roth Van Halen belt or whether it's the Sammy Hagar Van Halen belt. And there might be 2 layers, you know, like the first layer you come to is really strong, and it's the David Lee Roth Van Halen belt. And then you come to the Sammy Hagar, and it's not quite as bad, but it's still, you know, a little rough. You can tell.
Shielding against it for people is pretty easy. So
because they were supposed to have had shielding back when we went to the moon, allegedly. There was a shielding in place. I think one of the astronauts said they didn't know about the Van Allen radiation, so they didn't. I don't think they had necessarily prepped for it on that journey. But if they did go through it and come back without any shielding or even with, then it would show that that Van Allen radiation are okay.
They did
have shielding.
They were inside of a craft.
It's made of spandex, hair, and sick riffs.
That craft is the shielding. It was metal. How do you shield from that? Thin pieces of paper will shield you well against alpha particles. Beta particles, you need a little bit more, and metal is just fine.
Okay. So, all right. Well, and that's so like with things.
So this is why, wait a second, the guy from NASA came out and said that the Orion mission is going to be, you know, a challenge because they have to go through the Van Halen radiation belt, and this is dangerous and it can fuck up their electronics and all this other nonsense and everything. Why did they bother making a video? If metal's just fine, shit, just put some magic fucking gold foil on it and everything's copacetic, right? That's all you got to do. Just put some magic gold foil on there. This fucking guy.
Things of the sky, like distance to the luminaries or something like that. That is something that I will readily admit that I don't have precise measurements, the size, the shape. I think that you would maybe be assuming distance or size and then calculating based off of that, because if you don't know the size, you don't know distance, or if you don't know the distance, you don't know the size. I think that those.
I mean, I went through the math. No part of the math used the size.
Okay, I would.
You don't need to know the size. And Nathan, yeah, I know you're not bad at math. I know that you followed along with that, right?
Yeah, no, I did follow. I would. That's part of what, like with this sky, with claims like that, I don't know exactly the specifics of the sky, which is why I would prefer to focus on the ground, because I think that that's a little more testable, and like airplanes and stuff, I think could be.
Look, I agree. Here's the thing: we're trying to figure out the condition of the Earth, okay? The form, not, you know, what the fuck something up in the sky goes and you're looking at, you know. What was I was in a discussion on Facebook earlier. The guy, I says, well, what makes you think you're on a planet in the first place? And he says, well, because you look up in the sky and you see planets. And I said, well, why does that make you think you're on a planet? And why do you think those things are balls of terra firma? I said, you don't know what the fuck they are. You've been told what they are, but you don't know what they are, right? And so why would you assume that you're one just like that? Why would you assume that? That makes absolutely no sense. It's like, I want to see if I got enough gas in my Jeep, so I'm going to go see if my neighbor has shingles on his roof. You know, I mean, that makes just as much fucking sense.
More known. But that's what I was yeah, I didn't want to bring that test to the site. Oh, and then with the sunset too. By the way, that Thai restaurant is good. Spicy food.
Have you been there?
Yeah.
Joy's Thai restaurant. I haven't been there for a long time, but yeah, they did not ask how spicy I wanted it.
Oh, look at there. I bet she's
which usually in Minnesota means it's going to be not spicy, but it was.
Yeah, their one's still like a 4. So the place is heat. But
this is where we've gone, right? That's great.
I am curious. Even too, like with the sunset, you do have something like refraction that can be at sunrise, and that even like I think the global claim, sometimes the sun is maybe set before it's actually set.
Yeah,
or
actually,
above.
I have a thing I can show.
Oh
if
boy.
you don't mind, on refraction in the air. Can I?
It's showing.
That? Yeah, all right, hold on. I need to switch on my.
You're good to go.
Okay, so here is Batman. There, he's looking at a building, and this is no refraction. The light goes straight. And so that light, if we take that beam of light that started there at the top of the building, and then we add some refraction, you can see that beam of light won't get to Batman's eyes. It'll, hit the ground somewhere before him. So then if we look at another beam of light that came out from that point, because the light emits in all directions from the surface, unless it's got something special going on, that light that initially would have gone over Batman's head is bent down. That's what Batman sees. And to Batman, he sees it at an apparent higher position. So this is downward refraction. And you mentioned that. You had a picture of downward refraction in your presentation. So downward refraction causes distant objects to appear higher. I have a significant amount of documentation on that on my website, mctoon.net/refraction. So I'm not just saying this.
But you can't be claiming refraction all the time, MCToon. You can't, because that's not always true. You do not always have the same effects. You have to look at the distance you're looking through, the amount of medium you're looking through, and especially at long distances, because you might have different shit going on a mile over here than you do here. There's a whole bunch of factors involved. Now, that little miroscope that I've got, you have to be viewing it from a certain angles to be able to actually see the hologram of that refractory effect. Okay. But another interesting thing about it is the image is backwards. The image is backwards from what it was. So in the case of what I have is a little frog, you can go and look on my videos. I have a short about the miroscope. Okay. The little object down inside of the miroscope is actually facing the other way. But when you view the hologram or the refracted image of it, it is completely 180 degrees to you. Okay. He doesn't mention that aspect of it. And you can't have, this is not happening at all times. We know this, and we know that the effect of the atmos and temperature and all of these variables has a measurable affected difference throughout the day, as we've seen in many time-lapse videos of like a coastline, where you see it like completely disappear and then come completely back into view just over a period of time, just over a period of a day. Not due to any kind of tides or anything like that, just basically because it's going, it's dealing with a different amount of moisture, different amount of temperature. This is especially prevalent over water, okay, because water is already reflective to begin with. But when we're looking at other objects, if you're having that, now you'll see that at the mirror line. You'll see that if you look closely, many times you can see where the actual horizon's at and where there's a mirroring effect coming down of that. One that's real prevalent is that one that they like to use, that flash test. If you stop it on the zoomed in image of the building, you'll see exactly that. You'll see that those bottom floors and the trees and everything else are a complete mirror of what you're actually seeing. And it's blurring into that horizon. So it's definitely not proof of curvature of the earth. That's ridiculous.
Blindly. But I'd like to see, could you bring up your thing of the Chicago skyline?
Yes. Yeah.
Because I have that thing from Skiba. I have it. It's on the floor behind me here. I want to point out something that's important.
This here?
That's the one. Yep. So now look at on the left side there, you've got the demonstration done by the scientists, as you said. I think it's a teacher somewhere. And you see there's a magnifying glass there. You see that ring there on the other side of the table?
I don't see what they're fucking talking about.
Yep, I should be able to, if you can see my
Oh,
mouse this
okay.
here.
Yeah, there. Okay.
Yep. So you're looking through the top of the magnifying glass, and the top of the magnifying glass will cause light to bend down because of the way that it's shaped. Right? Then on the right side there, you don't see it.
So when the Atmos acts as a magnifier due to moisture in the air, it would be the same thing, right, Toon? Right.
But that box there on the bottom there, that bottom of the three there, you don't
This is getting irritating.
really see it in this particular picture, but Skiba is using the bottom part of the magnifying glass there.
Show the one where Rob Skiba went across Lake Michigan to Chicago, keeping the skyline in frame the whole time. Now, I'm going to tell you it was something that happens with that kind of refraction or miraging. As you get closer to the object, the mirage will disappear long before you reach it. That would be assuming that the mirage you see could actually be right side up. Okay. Which, of course, it's not going to be. So show that one by Rob Skiba, MCToon. That's the one we want to really look at. Okay. This right here, you know, you can try to simulate shit all you want to, but the reality is in that video.
And the bottom part of the magnifying glass will cause light to bend up, not down. So this is a straw man of the flat model, or a straw man of how refraction actually works, because refraction, you need to use the other part of it. And I don't have it handy, but I actually did the same thing, and I moved the magnifying glass down because I've got a table with leaves in it, and I dropped it down a little bit so that only the top part, just like in the demonstration there on the left side, so only the top part of the magnifying glass is being used, and it causes it to set, or it causes it to be a little bit higher. So it sets a little later, but it's still, actually it doesn't set because it's over a flat table. So it makes it higher.
But it still appears to go down. It just is further back.
It never set when you do it.
Okay.
When you refract light the correct way, it doesn't set.
So how I would respond to that would be if you do use another portion of the lens that does cause it to require to go further away to get that apparent of setting, you also have, when we look out to the sun, for example, for a sunrise or sunset, we also have the ground itself and the sky converging on a point.
Come on, man.
Where that is going to create a vanishing line and things, and so you can hide information, visual information beyond that line.
And I'm going to need empirical evidence supporting that claim. I've heard that claim many times, but never seen any evidence for it. What you described, though, is an application of...
What? Did he really just say that, man? That fucking dude's lies his ass off. That's all he does is lie. What a dishonest piece of shit.
Perspective. Things get smaller as they get farther away, but the sun can never be close to the horizon on flat Earth. The example here that I used for many.
Yeah, the example you used using a third-person perspective and two-dimensional orthographic fucking bullshit. We've already called your shit out, MCToon. Get a new fucking pony.
Minneapolis was over 21 degrees in elevation. Nowhere near. Not
so
even close.
Well, it was 21 degrees based on an assumed height and without any medium or medium change.
Measured height. I measured the height, hypothesizing flat Earth. So not assuming.
Yeah, it was measured 21 degrees, but there's medium and atmosphere that it's traveling through, plus any firmament structure that it would be passing through.
I'm just going with empirical evidence, though. There's no empirical evidence for the firmament. It's just an empty claim.
Well,
not science. It's just a religious belief, right? You don't have evidence for it.
That is, I do not have a piece of firmament in my hand, which I think would, if the firmament.
I wouldn't, no, I'm not expecting that. Right? I said radar. I mean, there's many ways to confirm that something exists.
Here's a way to confirm it exists. Prove a gas pressure system without a container, MCToon.
Rather than just going there and chipping off a piece of it.
Yes. Well, so like if so you say with perspective, if you have perspective, you get something like the objects that are further away, they will shrink. And then there is also a change in apparent size. And that's actually one thing magnification does help to keep.
You said the same
size.
thing twice. They shrink and they get smaller, right? That's the same thing. They do get smaller, and solving triangles is how we can resolve those things. That's how you apply perspective.
Yes, they have an apparent size, and then as you go further away, if you have refraction bending the light downward, the sun won't have to go as far away because it will be being bent down. So that will cause the light eventually to not reach Batman's eyes for the sun, and it will hit the ground instead and run.
Yeah, but the light emits in all directions from the sun, so you'll still see it. It's just the light that would have otherwise, without refraction, gone over Batman's head.
Well, that's where I think you can get into things like the optical effects of light with a dome, where you can get light to, like, this here is a light source, and it's going further out towards what would this be, South America over here, but it's not even, it's hardly going past the North Pole here. So there does appear to be, and this is a very crude example, but I think if there is an all wise, all intelligent, all knowledgeable creator, they would be able to set up a system so well engineered that it allows us to perceive a sun that can keep it's at the right distance and angle to the material.
Dude, that's a hypothesis that you can't even begin to think about testing. But here's my question for this one.
Yes.
My response, that acrylic dome that you have there, it has an index of refraction of about 1.5, and the light is in an area of air which has an index of refraction of about 1.0. In reality, the air above us is not an index of refraction of 1.5, it's 1.0. And if there is your hypothesized dome, then it has the index of refraction of 1.5 or something more. So you actually have it inverted. This example is the opposite of what your claim actually is.
Where is he getting that one? He made that shit up. He doesn't have an index of 1. Depending on where. What's the conditions? See, he don't fucking back up his shit. I think he makes up shit.
So light would be bending upwards because of the dome. Because this dome is showing a lighting pattern that matches
it is
time and date rendering.
Look, man, what is the sun? Where is the sun? Okay. That's got to be decided first before you start talking about any of this dumb shit right here. Okay. Nail it home, Nathan. How can you have any air without a fucking enclosure, dude? Come on.
Not quite. But let's imagine, I'll grant you for a second the imagination that it did match somehow time and date.
Thank you.
It won't match the direction that the sun appears to come from. Well, that won't work. But let's ignore that for a second. The problem is that air.
Hey, Glenn, I think that index changes though with conditions, because we get higher and lower degrees of refraction all the time. So it's not a constant. That can be an average, but we're going to get more and less all the time.
Air does not have an index of refraction of 1.5, and that's what your example here is using. And it's using an index of refraction of 1.0 outside the air portion of it. So you've swapped it. So what you need to do to test to see if your hypothesis could even begin to work is to put air on the inside, and on the outside have some sort of a structure, your dome stand-in or analog.
Some sort of crystalline and maybe water behind it.
Yeah, so you've done the opposite. So this isn't evidence for flat Earth doing light patterns as you hope it does, because it's the wrong materials, the wrong index of refraction.
Yeah, that would make sense. So this would have to be something that would be recreated in an inverse, having a pocket of air inside the dome.
Look, I'm gonna have to dig this out, and I'm gonna make myself a note to do it tomorrow. I've got this video, man, of this jet taking off, and it's time lapsed, and it's right in the cockpit. Right now, it's not one of those to show curvature and non-curvature. What occurs is as this plane starts going in altitude, you see the sun change apparent size like 3 or 4 times by the time he reaches his ultimate altitude. And with the time lapse, you can see it. Now, normally it would be kind of gradual, but with the time lapse, you can actually see it. He comes up out of one layer and it's like, phew, and it gets small again. But when he sees it normally and it's one shape, one size. And then as he comes up through one layer of air or some shit, like it increased in size and then decreased in size and then came to another size. So this is changing shit that we view all the time. I think, yeah, you can have an average index, but it's going to be within a range. It's got to be within a range because it's an effect of the way light is behaving with the medium.
And then different mediums outside. Right?
Yeah.
Okay. Well, that'll be something that I will have to I'll have to look into that. Do you mind if I bring it to the ground?
Okay.
So let's go. Let me see here real quick. This here is just an image of a bay where you can see it's the same day, but at sometimes you can see the so much of the horizon, and then at other times more is exposed. And so I'm curious, like if we have these different days where there's different amounts of
he's going right where I was
refraction or the temperature is different, how do we get how do we get these observations that appear to have multiple data points that if you line them up, they're linear? Is there any demonstration that you're aware of that can show a surface that is curved that can recreate using refraction, using lensing, any variables that can create a known curved surface to appear planar, like beyond mathematics? I'm talking like a demonstration.
Yeah. So there is, I'm not exactly remembering where it is, but he's on Discord a lot.
You son of a bitch.
And he has, somebody in the chat can maybe help me remember his name. He's super nice guy. He did a salt or sugar in a tank of water, and he created he used a curved piece of metal, I think, and he suspended it in the middle of the tank. From the side, you can see that it's curved. And then, but from the end to end, you look through it and it appears flat. No, it's not doofus. Man.
So you're looking the long way. You're looking out towards the horizon.
Yes.
And
I'll see if I can find it. Yeah.
Yes, if you could please, because that is something that I hope makes sense. Like here, where like with one of the things that biblical earthers get a lot, or flippers get a lot, is like bottom up disappearance. And this here is a flat surface. At least it's a floor. It's flat enough, and I'm sure carpenters and everything would talk about that. It's flat enough, and these objects are certainly large enough to be to scale. And this is showing that the flat Earth can actually demonstrate hiding objects that would be bigger and harder to hide.
Yeah. So I'll ask, what is the conditions that is being simulated there?
So
what is the lapse rate that's being simulated?
The exact lapse rate I don't have. I will say that it is using the variable of temperature variation, because over something like water and land,
Yeah, temperature variation, you've got moisture content, you have position of the lighting source, just to name a few big ones.
And water has a different heat specificity, so it holds
Hold on. Back it up a little bit here. Just back up 2 sentences and say it again.
The water has a higher heat specificity than land. So water
What
stores,
does that mean? What does that mean?
Water stores heat. It takes more energy to heat water up than it does to heat land up. So
okay, I get it. Hold on.
Yeah,
it's called specific heat.
Yeah,
you're wit sitting on me here. It's not specificity.
I don't mean I was taught heat specificity as a
specificity is a word.
Okay. Yeah, well, 4.148 or something like that.
It's specific heat. 4.
Yeah.
Well, yeah.
I think
water is the definition.
Now, do you see what he's done though? Do you see what MCToon has done? We're off the point. Took the kid off the point. Now we're going to talk about a word. See?
Yeah. Specific heat. Water takes a lot of energy to heat up, and so the point of it is that temperature would be different over water than over air than over land. So there are a mixture of temperatures, and you can have hot and cold, and so that can cause.
Yeah, that's why I asked. What is this? What is this simulating? What is the actual index of refraction?
It's obviously just showing that it changes throughout the day through a time lapse.
Refraction gradient that this used for this demonstration.
The index of refraction, I'm not sure that this is just showing that the claim of changes of temperature is enough to cause a hiding of the bottoms of buildings, of shorter buildings, and to cause us to reveal something that would be similar to only seeing the top portion of tall buildings or the bottom of the top sails and masts of a boat. This
you fucking whore
shows that there's a variable that we can use and
okay. I asked you because I didn't know if you knew, but you don't. That's fine. In order to cause this type of effect, you need to have a specific index of refraction gradient, or a lapse rate, as it's sometimes called, where you have an index of refraction that's low near the ground and high as you go up, which is the opposite of what we see in reality almost all the time. So this is
the video is showing what we see in reality all the time. This is a time lapse of objects in the distance, showing that throughout the day, within a few hours, the refractory index changes it all the time, man. That's the point. Not worried about which temperatures are where or whatever. We can get into the specificities of it beyond that. The point is, here is what happens when we look at distant objects due to changes in temperature, lighting position, and content of the atmos.
This is showing the opposite. The
refraction. Can you say that one more time?
Yeah, it's sorry. It's because it's inverted. So in order to cause things to appear to get blocked by a flat surface, you need an index of refraction gradient where the index of refraction is low near the ground and increasing as it goes up. But that's not a stable position, because generally that means that you have denser air higher than lower, and they want to reverse then. So you'll get this churning effect.
It changes all the time, MCToon. This is why, when you look at your satellite weather shit, that is nothing more than information sent back to Earth from weather balloons and then extrapolated over a map of your area. You see continuous change, don't you? You see continuous change. You hit that little thing, you know, that's let's see what happened in the last hour. And you hit that little play and it shows you that shit. What the fuck do you think that is, man? Those are temperature differentials, moisture differentials, all fucking colliding with one another, expressing themselves as they equalize in what we call weather. Okay. And so these conditions within the atmos play fucking hell with our vision, as this time lapse shows. Okay. The camera did not change position. It merely took pictures every so often and put it together into a time lapse, showing that the refractory index from that position changed several times throughout the period of taking pictures. Now, I'm assuming that it didn't go much further than a few hours because, you know, it didn't become nighttime, you know. But Jesus Christ, I don't know why people don't understand this shit. I really don't.
And they swirl around and things like that. It's unstable. Where it is stable to have a low, a denser air with a.
Yeah, I make up words. I come up with words. I'm allowed to do that. Okay. It's like, you know, faganicious proclivities. Figure that one out. Right. You should not display faganicious proclivities.
Higher index of refraction at the bottom and less dense air as you go up, which has a lower index of refraction.
That's right, Peter.
So then, if I may ask, going back to the planar recreation, you had mentioned that there was a tank with salt water that was used to give an appearance of linear, despite the metal itself being curved.
Yes.
So isn't that going from a low density medium into a very high density medium into a medium density medium, and then back through the glass on the other?
Peter's got it wrote right there. Temperature fluctuations come in varied heights, distances, and no mathematician could target through those variables because they would start having technographical deformations right off the bat. There's another one for you, Derp. Technographical deformations.
It's low density at the as you go up. So it's highest density at the bottom. But this demonstration.
Oh, I thought you were talking about my variation on the word, but yeah, I come up with shit sometimes. Faganicious proclivities.
You have here. Well, it's not on the screen anymore. But the demonstration you had that one there. Yeah, that would require the inverse.
So wouldn't this, if the person is looking through the fish tank, aren't they like they're looking through a low density and they're looking horizontally as opposed to considering like the changes as you go vertical? They're looking horizontal and they are looking through themselves. They're looking through low density, extreme high density, and then the density changes as you go through salt water to get an apparent flat look to something.
Yeah, listen, dude, is exactly what Peter just said a minute ago. You're not going to get this effect every time. Okay, so you can't claim that every distant object that is viewed beyond where it should be seen, oh, it's because of this refracting. Yeah. You know, shut up.
Is this like these examples here are all through air? Like these are all through air, and then this here is through air as well. And
well,
so
it's simulated. It's simulated.
Yeah, it's an attempt to try to isolate or say, hey, we claim a variable, and then we want to try to show can it. And I think that's the point of this demonstration, is just to show that it is possible to use natural conditions. There's no blaster furnace or extreme.
Which one was it wore the Metallica shirt? Was it Beavis or Butthead? I think it was Beavis. I think this might actually be Beavis.
Freezer or anything like that. This is using natural conditions to show that it is actually possible to get the bottom up disappearance. And I am curious as well, because I know people have made measurements and observations, say just across lakes, large lakes or bodies of water, and they've done it at freshwater, saltwater lakes, bays, and everything, various distances, long and short, relatively speaking.
Okay.
But then
I
they also
have it ready if you want to see.
yes. I will stop sharing, but we see these various FARD sightings in various conditions, and I'm just there is actually something that I'll pull up once you're done, but it has to do with in chemistry. I had learned for refraction that you have your standard temperature and pressure that you make a measurement at 20 degrees standard pressure, atmospheric pressure. And if you add 1 degree Celsius to that measure, to the conditions, you have to take your measured refractive index and then you have to add 0.0004. And if you go colder than 20 degrees for every 1 degree Celsius, you have to subtract 0.0004. So the hot and cold temperatures actually change your refractive index, and one will bend light further or less than the other. And we do see far in both conditions of cold and hot, despite them having opposite bending effects on light. And I'll show the document after that, but yes,
right, well,
go ahead.
Like having several layers of different temperatures, right? What would that do?
Go ahead.
Yeah, here's the video. Are you getting this, Ryan?
Yeah, we got it. And
Okay.
yeah, if you're hanging out in the live chat
Shut up, Ryan.
right now, we still got, well, we had a planned 20 minutes of open discussion before we move into the Q&A. So if you haven't gotten a
God bless America. This is getting irritating.
question in there, there's tons of questions. So once we move into that, I think we're going to be here for quite some time, gentlemen. So just brace for impact. But
hey, with Mike, it's never long enough. Who doesn't want to hear him? He's
Come on, man. Fucking
this is
bullshit.
science. This is actual contention. Mike is awesome.
You guys are awesome. Honestly, this has been one of my favorite ones to host because I get to sit here and just listen to you guys chit chat. And aren't you guys glad though? Let me know in the live chat if you're happy that you can see the speakers on screen. I know I messed it up at first, and you could see me typing in the live chat. Ha ha ha! Ryan's silly. But isn't it nice that we can see our speakers while they're doing the screen presentations? Because there has been a few of them. So hit the like button. Over to you, MCToon. Without further ado.
All right. So
I don't know how you could do this
there
without
you see, I'm going to play it. You'll
demonstration.
see that bar in the water is curved right there. And he's showing now the laser going right over the bar, and the laser matching the curve of the bar. He's got like some little topography that he added. And the laser's actually bending more than that bar. And then he'll show us from the end here. He gets down closer to it, and you can see when you get right down to the end here, that bar, which is curved in reality, looks straight.
Yeah.
So there you go, right there. So that bar looks straight, which we know is curved in reality, and that's what bending downward of light causes, and that's again.
And why can't they put this same thing into context when talking about things in the sky? They can't. They don't want to. Then oh no, we're looking through a vacuum and all this other shit. How the fuck do you know what you're looking through? I've shown on here a few times the kid in the curved pool. You know, he's standing over here and his body's facing a different way over here. Right from this observer point, and it changes, and not until you get directly in front of him does the refraction stop. So I don't understand what you're trying to get at. Are we looking through water? I mean, that's a serious decrease and increase. Yes, it's a good demonstration of how temperature can affect a path of light, or what appears to be a path of light. But is that what's going on in reality? No.
The index of refraction is highest at the bottom, which is similar. It's the analog to cold air over water, for example. And then as it goes up, the index of refraction reduces, which would be similar to the air over water getting slightly warmer as it goes up. So there's the.
Would you be able to
analog.
Would you be able to back that up a little bit? And also, if you could send this to me, or I'll probably watch this again because this is something I'll definitely be needing to look at. Just curious too about those nodes that he has sticking up on the metal. Those are
it's some sort of it's like a clay that's meant to simulate topography. Like,
and he's shining the laser by the clay.
Yes, by it.
Okay. And then I just noticed there at the beginning, so it kind of looks like that laser is entering into the glass straight.
Yeah, it's coming into the glass orthogonal.
Okay, so the laser is level, and then it goes upwards with the curvature. So then I would ask.
All right. So you could be right there. The laser might be not quite orthogonal, so that it matches the angle of the left side of that bar.
Okay, and I'm curious too because this is showing. I would wonder what the observation would be if you. Because like if we're talking about like the Fort Lights experiment or those observation or those windmill bases, that would be on a globe you would be looking tangent out, and then they would be dropping down, whereas this bar is kind of going with a hump, and so I'm curious if this would have the same effects, going tangent as opposed to going. Riding the curve, the curvature of the. I imagine it would because this appears a little more severe. So the light is going. It goes once it enters into the salt water, it travels upward, and then once it gets to about that halfway point, that's where it will start to then bend due to refraction.
As soon as when it's in the water, then it's going to begin bending due to the index of refraction gradient.
So how does the light go upwards to get up the curve?
The angle that the light is outside the tank, it's slightly bent up. So like I said, I misspoke when I said it's orthogonal to the tank. It's not. It's tipped up a little bit.
It goes, which could maybe I don't know if that could have something to do with reflection. As far as the angle you receive is the angle you reflect.
Once it's past the glass or whatever the tank is made out of, then its effect on the path of light is done. It can't affect it later on. It's already gone through it.
It could maybe tweak the initial entrance into the medium, though, into the tank.
It certainly it very likely does, because it's not coming in orthogonal. It's got a little bit of an upward angle to it. So like the cover of the Dark Side of the Moon album by Pink Floyd, not as severe because because the glass is parallel, both sides are parallel. It's not angled like on that album cover.
Yeah.
Okay. And prisms specifically are chosen because they have a high index of refraction, and fish tanks, it's not super desirable to have a high index of refraction. Of course, strength is more important, but when they're parallel pane when the pane of glass is parallel, it doesn't have that same effect like on the Dark Side of the Moon cover, but it does affect it. It is going to come in, it's going to refract towards the normal, and then when it comes out, it's going to refract towards the normal again.
Okay.
We have refraction at the vanishing point. Okay, so how does this prove a globe? Okay, it still doesn't explain how an image can be lifted up miles beyond where it should be behind curve. It just doesn't. Okay, you're getting down into stupid shit now. Just stick with the fucking basics. Stick with the basics, man.
So that would be refracting towards. So it goes, okay, so it goes up, and this will be, I'm gonna have to look into, because the laser does appear, the spacing of the laser from the metal, it does look to be riding the contour of that metal.
It's angled going in. I don't know why the guy just didn't set it up orthographically, so it was at level, which indicates to me that it probably does make a difference. But we'll go ahead and, for the sakes of shits and giggles, I don't understand how this is supposed to. We know there's refraction, of course. That's the point. However, this is debunking your whole thing, MCToon, because where are you getting that R value, right? Is the horizon apparent or is it physical?
Yeah.
Do you mind if I, real quick, let me pull this up. Could I just show?
Sure. If you can end your screen share there, MCToon.
Yeah, there you go.
There you go. Over to you, Nathan, when you're ready.
All right. I'm just trying to find the here it is.
This is my chance. Smash the like. Smash it.
Yeah.
If you're watching on MCToons too, I mean, hey, why not? I think you're still streaming over there. Join over here for a second. Hit the like. Join in the polls.
Hey, like it if you like it, right?
While we're on this little aside here, N-99% God wants to debate me. I would mention it in the modern day debate chat, but I still cannot chat there, Ryan.
Don't look at me. I'll figure this out. I swear. I'm gonna figure this out.
Get this dude in. Get him in.
I'm gonna figure that out. But yeah, honestly, I just gave that individual mine and James's email, so you can email me at bc.adt@outlook.com or james@moderndaydebate@gmail.com if you'd like to participate at Modern Day Debates. I know James is pretty busy writing his thing right now, so if you want to get a hold of me, that's cool. If you want to get a
why can't you comment? Oh, did you say some fucking terrible shit or something? Whatever, man. Dude gets really emotional over this shit. Ryan or Pitchlumin here, whatever, he's I think he needs to get a little more assertive, man. Call some of that shit out. It's like, wait a minute. I just showed you because you can go right from that refraction thing right into the R value, bro, right into it. You could actually segue that into how do we even have these this dynamic pressure system without a fucking container. These are the basics they gloss over. They count on you having already accepted this bullshit because they ran it at you at a young age. So they're going to say, oh, let's look at this and let's look at this. And it's like, wait a fucking minute, man. It's one thing. Yeah, I don't see any curvature, but I'm also wondering how I'm able to breathe and talk to you and have this discussion. Let's go there. Fucking people, man.
A hold of James. You might be waiting a little bit, but then you'll be getting to talk to the top-notch boss there. So let's carry on, fellas. You had your
okay.
screen share ready?
So, yep. Is it? You see this here? This paper?
I gotcha.
Okay, so yeah, this is talking about the index of refraction. So this talks about the velocity of light. It's not constant in all medium. The bending of a beam of light as it passes through the interference of two different media as a consequence of the variation. So it talks a little bit about how to calculate the index of refraction. And so this here is actually the standard temperature for measurement of the refractive index is 20 degrees Celsius. If the temperature deviates from this, a correction of 0.0004 degrees per degree above 20 must be added, or a correction of the same amount must be subtracted from the value read directly from the refractometer. So this is talking, and then it gives an example here about how you would alter the measurement. And so this actually I would put in line with, for example, the four lights observation was done in winter, and then actually even in the why
don't we speed these guys up a little bit? This is so far, it's not very entertaining. Go up just a little bit.
this here.
Oh.
So this is winter. This is a frozen lake. And then
There you
this
go.
here.
You're not
this here
showing yet. It says that you're starting. There you go. It's ready.
Okay. So this here, the bases of these windmills would be in a warmer weather condition, and then these here would be in a colder weather condition because this is a frozen lake. So this is showing that despite temperature's influence on light, bending it in alternate directions, changing the refractive index that we actually measure, we have to apply correction. We are able to see very far despite the weather conditions. And then this can go into things like, I think it's the Mount Canigou, the extremely long distance observations that we were able to make despite the claim of a globe, which, and one thing to consider about the planar Earth or the globe Earth, planet Earth, is and this might be a false sense of illusion of knowledge or something. I don't know how to, the words there. But with the globe, we're claimed that we know the, we know the distance of the sun, the size of the moon, how far away stars are, and what they're made of. So there's a lot of claim to knowledges of the sky and these sorts of things. But I think that there's a lot that we are still trying to understand. But we do, the claim of the globe is that the Earth has a given radius and a given curvature rate. And I know the 8 inches per mile squared is an approximation that is like up to a % off. I think out to like 1,000.
8 inches per mile squared is perfectly fine when used in the right method. But
yeah, because it doesn't factor in observer height, right?
It's not a method to determine the amount of bottom-up obstruction. It's a fine method to measure or to predict a linear drop from a horizontal tangent. But a lot of people say it's the curvature rate. The curvature rate is not. The curvature rate is 1 degree per 69 miles or 1 degree per 60 nautical miles. That is the curvature rate.
Yeah, 8 inches per mile of Earth traversed would curve. But that's you would basically be resetting your.
It's a drop. That's all that's giving you.
All he's doing is making it not sound as severe by changing it to bigger units of measurement. Okay. That's all MCToon is doing there. He doesn't like this, and that's the trick. Okay. It doesn't matter, MCToon. Make it metric. It doesn't change it. It's still the same rate. It's still a specificity. Okay. It's very specific that you have this size. Okay. And this speed of rotation and everything else. All right. I don't give a fuck if you want to put it into astronomical units and use a little tiny fucking decimal place. Doesn't matter, man. It's still the same rate of curvature and it should be measurable. And when we can see objects, we measure using the 7.9 meters or 7.9 inches per mile squared. Okay, minus the observer height, we still see things way too far than we should, Mr. Toony Toons.
Drop from a horizontal tangent. And I've used that in several things. Jaron used it in his experiment in the movie, and it's the correct formula in that instance.
I beg to differ from you. Okay, so I had my wife go up the curved spiral staircase at the Mimsland Hotel, right? And I stood in one spot and I watched her disappear over the horizon, right? And so then I took my zoom on my camera and I zoomed in onto where I saw her go around the horizon, which was a Verizon actually. Okay. And you know what? She didn't come back in view. You know why? Because she was physically obstructed by a curve. Okay, Loose Sapphire, she was physically obstructed by the curve. I think that video's on my channel too.
He still made an error in his math, but it's the correct formula. So you need to use the correct formula correctly. He almost got it.
Okay. And actually, real quick, I would like to say this too, hopefully to maybe get a little bit of heat off of Jaron. But if I might just real quick address that movie, the documentary, or what some people call a mockumentary, Behind the Curve. Jaron had said, and I believe there are some globe defenders, maybe people who are not too fond of the flat Earth idea as well. People have contacted those there, and people have on both sides said that night nothing was shown. Man. And Jaron actually, I believe some people made some money or something off of his interesting quotes, and he did not. And so I would just like to point out that documentary, there was things about the directors and them not being quite honest with him or telling him all of their works before he agreed to do that. And then there was also like they had wanted to make it a balanced representation until I believe a kid rose up at a convention and had said that some of the flat earth stuff was kind of making sense. So they decided this is a little bit serious. So we should kind of slant the message a little bit because, yeah, I think that both parties left that night with that experiment with Jaron that they had said, yeah, it's not really conclusive. We've gotten results kind of showing both. So I just kind of wanted to state that as well. And we can talk about like the measurements of the 15 degrees.
I've throw that out there. I've analyzed what he did in a lot of detail. I did a video on it a while ago. And someday Jaron might be ready to talk about it, but he's not ready yet. All right. I have something to show.
Don't ever let him do that either. Okay. Don't ever let him back you into having to defend someone else. Okay. We're not talking about someone else, right? I don't have to defend them. They can defend themselves, right? So that's right. Don't let them back you into that. Well, what about Jaron? Or what about Bob Nodell? Or what about them? Fuck you. I'm not them. You're not talking to them. You're talking to me. Okay. Go talk to them. All right. About whatever it is you got. Right. I'm not them.
Oh, you were talking about Frozen Lake.
Yep.
Dude, there is empirically confirmed measurements of the effects of the index of refraction change. So, and the biggest driver of it in the low atmosphere is temperature. And over water has a high heat
Specific
index or specific. I didn't want to say it wrong. I'm like, darn it, you got specific heat. So it has a high specific heat. So it changes temperature during the day slowly. So in the afternoon, when the air's had a lot of time to warm up, the water is still much cooler than the air. So on a sunny day, the lapse rate is maximized in the afternoon and it peaks after sunset. Cold lakes, and
I think it's also important that he recognizes that this heating effect is taking place, and there's also different times of the year. The amount of daylight that's been hitting the lake every day, because the water, the deeper you go, the cooler it gets, and so you've got that warmer water dealing with the cooler water, which also changes all the time throughout the year as well. So there, like I said before 100 times, there are oh my God, what in the fuck are you talking about? Curvature in accordance with the concept of gravity? Well, we're not dealing with concepts, loose sapphire. We're dealing with reality. A spherical earth assumes, yes, it assumes a shit. Yes. And we are at the highest place everywhere you said, likewise ships and buildings. Yeah, it should be not like a cylinder, which is what you guys always show. You don't show any curvature in all directions. Okay. So your concept of gravity is merely that, a concept born from a fucking Egyptian religion brought to you by Thoth. Okay. A bunch of Greek dudes sitting around in a bathhouse thinking that balls were the perfect shape and shit. So everything must be balls. So a bunch of Greek guys sitting around in a bathhouse talking about fucking balls is not the entirety of Greece or mankind. Okay. Right now we have a segment of our population that believes that men can become pregnant or that people can be animals, be a dog or some other shit like that. Does it make it so? Absolutely not. It's just weirdo shit. You would always, here's the problem. Here's the problem. As you rise in elevation, the horizon would eventually start to drop beneath you. It doesn't. It always remains just slightly below eye level, about the same distance that it always does. You would see it drop below you as you rose in elevation. We don't see that in any experiment, dude. Oh, it sounded like you were trying to talk about a freaking curvature in accordance with the concept of gravity. Yeah. All right. I'm sorry. Friendly fire, man. No, since 1980. What did I know in 1980? What I knew in 1980 was that one chick that sat up front in math class had a pretty damn short skirt. That's what I knew in 1980.
You live in Minnesota like I do, and maybe you've walked on a lake like I have. You can be comfortable. You could have your coat unzipped, you could have your hat off, and your feet are dying because they're so cold when you're walking on a lake, because that ice is not going to melt. It's going to be at freezing temperature. It just absorbs all of the heat. So there's a very high index of refraction gradient, temperature gradient first. Above a
water
lake.
does, just as a fun fact, water does have some interesting freezing behaviors around the 0 degree Celsius mark there. It's like 0 to 4. It's incredible.
It is very unique. If water did not do that, life probably could not exist, because lakes would freeze bottom up instead of top down. Anyway, and every year in the spring, we get to see that in lakes. You'll be walking along, you'll see a lake, it's frozen, and then the next day, completely gone, because the whole thing inverts. It's pretty cool. Okay, so the index of refraction gradient, or the lapse rate. The lapse rate of 1, this is the key number, empirically confirmed, 1 degree per 10 meters is the number that is an important number. So what happens is, as we saw, that
10 meters raise in elevation.
Vertical, yes. Okay. So that beam of light, that laser that we saw, has a curve to it, and that curve has a radius. In the air, the radius of that curve is equal to the radius of the Earth. When
bullshit, it would change. It would change due to the refraction index. This is why rainbows are different sizes.
The temperature gradient is 1 degree over 10 meters vertical. Right?
Can you say that one more time?
So the lapse rate is the vertical temperature gradient. When the lapse rate is 1 degree Celsius per 10 meters, then the radius of the ray of light is 6,300 kilometers.
So that would match the measured empirical lapse rate of 1 degree per 10 meters happens to be what is required to bend light along the contour of the Earth.
The same radius of and it's and it's rarely exactly that, right? If it's more than that, then light will bend down more and hit the surface more and reflect off of the surface if it's a shiny surface like water tends to be. I had one more thing before again, on my website, MCToon.net/refraction, I have several of these. I have a list on there, and the final one that's on there is the one that is particularly to the point, where they use the lapse rate and they measure the curve and how much, and match them up to determine empirically how much they match. So the point is, 1 degree Celsius is enough to curve light if it's over 10 meters. So if it's less than 10 meters, you get 1 degree change. It's a big deal. It's gonna curve the light.
That would be a lot of refraction.
Yes. So here is my personal measurements using a NIST certified thermometer on a lake in Minnesota. So here we have this is just above, 18 inches. So it's half a meter, right? I did these. I have an imperial tape measure, but I did it at metric elevations. So half a meter.
Go metric. We really should. Ryan's way ahead of us in Canada.
Do science and metric. So 0.2 degrees Celsius at half a meter. Here is at 1 meter, 0.7 degrees Celsius. Here is 0.9 at 1.5 meters, and 1.2 at 2 meters. So we actually get a full degree change in 1.5 meters, which is a significantly higher lapse rate than is necessary to bend that ray of light more than the radius of the Earth. So I don't know if that hits you. I don't know if that sinks in, but this means that over ice.
Yeah, it's telling me that you're being tricked into thinking the Earth's a globe based on the refractive index that you're trying to tell us. Okay, so we knew that.
Over ice, the index of refraction, the coefficient of refraction. Coefficient of refraction is how much light bends in relation to the radius of the Earth. The coefficient of refraction is very high.
Okay, so I have 2 questions here. One might be, would the lapse rates be as strongly increasing here on ice? Would it be similar if you were doing it over warm water? Because we've made long observations over warm conditions. And then I would ask too about the lapse rate or the implications.
Just bullshit. Go right on to the long distance observations and having try to explain fucking refraction index with that shit. In fact, I don't even know why you're even bothering with this clown with this fucking shit, man. Yeah, and I know, right? Exactly. Nothing he's saying is real. He's literally just making shit up. Well, this guy thinks math is science. That's a problem.
On the refraction of, like again, for the linear observations we make in the natural world, and then the attempted recreation of a curved piece of material, is the lapse rate using glass mediums and salt water, sugar water, are those comparable to conditions we could find in looking over water in our natural world?
Well, those are like the one from Jesse. That's a proof of concept that he didn't do anything to measure the index of refraction gradient, and of course the lapse rate that's in the air is significantly different than the salinity lapse rate.
Yeah, which was much more extreme, wasn't it?
In a tank of water. I don't know if anybody's done any of the application of the salinity lapse rate in a tank of water. I think that's probably outside what anybody would have previously been doing. But
that's a frontier of science.
Certainly somebody could do that. But I think that the point is,
I totally believe that, Sapphire. I totally believe that fucking shit. That dude is just a troll, man. He's terrible.
It was a proof of concept. And you asked the question, so this was just the answer, that can an index of refraction gradient cause something that is definitely curved to appear straight? And as we saw, then yes.
And I think that is important to note too, that these are like, maybe you would agree, Mike, that it's important to be able to have kind of maybe these rough outlines of proof of concept where you can kind of show it, and then to be able to, if you have the engineering, the apparatuses, the level of precision, you can get more into controlled experiments and isolate more variables and set things, and then you can use those laboratory empirical extrapolations, and you can turn them into things that you're then able to predict with. But I think it's good to have.
Sapphire, yes, I agree, and I have a theory on that. His last canceled appearance on this platform of MDD, that was really telling. And I've often thought, look, these guys they can't be doing this because they give a shit or anything, right? And they come right out the gate just fucking loaded up with subscribers and the whole 9 yards. So this is what kind of blows my mind with it. And I got to thinking, well, wonder if they've been like got in trouble for some shit, and this is a way to not have it be on a record or some kind of shit like that. I don't know. Did they get caught doing something that they probably shouldn't have been doing? And this is like some kind of off the books deal, or I wondered. I've had that suspicion for some time, and something in my gut tells me that I'm right. And after Dave Weiss's encounter with him in Nashville and his description of it, I was like, oh man, okay, right. And then the other night when he flipped shit, when he wasn't even really accused of anything, he just lost his fucking mind. I went, okay, I'm just throwing that in the fucking bank here, just throwing it in the bank. That's all. So yeah, him, I think, FTFE, a number of these guys. Yeah, absolutely.
These proof of concepts to show that things are tenable and plausible, and that they can actually then hopefully be tried to be used to establish a further understanding of our world.
Just to inject right quick, Nathan, because I know that you're just about to go on this next thought. Before we get too far back down into what we were discussing, we got lots of questions in the live chat, and that is going to keep you guys potentially tied up for a little bit. But I want to check, how much longer do you guys want to keep the open discussion going before we get some of the audience interaction, push the conversation along? Because I don't mind if we have a long Q&A where you guys are, expounding on what people are talking about, because it seems you have a lot of ideas. But what are you guys thinking? Maybe 10, 15, or did you want to get there quicker?
I have one question or one topic that I'd like to bring up, and maybe Nathan has one.
All right, let's give it 10, and then we'll get to the Q&A there, guys.
Okay. We can try. We might be swift here. We'll see.
All right. Well, We'll see. Don't worry, fellas. Don't let me rush you.
In your presentation, you said that the seasons on flat Earth are caused by the sun moving in and out. And I have I've got the little Gleason projection from the globe map. So the sun doing small circles in June and doing big circles in December, and varying between them. So the radius of that rotation is varying constantly in a sine pattern. So what is the cause of the variation in the radius of that circle?
Supposedly Toon doesn't have a record, and this is how he's keeping from having one. That's my point.
So the philosophical framework for a flat Earth, as far as like the medium that carries light, would be the ether. And so there would be a rotating vortex that interacts with light. It also appears to have some impact on matter based on the Elias effect, an eclipse with a pendulum swinging. So if you think of like a bike wheel, you have the center, and then radially out, the whole bike wheel turns at the same rate of, we'll just say 15 degrees per hour, or 15 degrees per unit of time. And so you would have, no matter where you're at, so long as you're on the spoke, that same spoke, you're going to keep your 15-degree heading. There would just be an increase as you go outwards. You would have a greater arc to cover. And so that would, from what I've seen and heard and gathered so far, it appears that sun rises and sun sets in the northern.
It's kind of like
summer.
I'm looking at this kind of like, you ever who was that guy? They did a movie about him, Catch Me If You Can. What was that guy? Abernathy. And they ended up catching him, and he struck a deal where he ended up working for him, helping to bust fraud cases and shit like that. And so that kind of a thing is not unheard of, especially since we've had the Hillary crew and their cyber army bullshit that she was talking about. That didn't go away. That didn't just go away.
They take kind of a while. There's light lasting for a little bit, for quite a while longer. Then in the northern winter, southern summer, the sunsets and sunrises have a much briefer twilight time, as opposed to what would maybe be a symmetry because of the Earth. And Mike, do you know, is the globe claimed to orbit the sun on a plane, or is the orbit as well tilted, not just the Earth's axis of rotation?
Well, yeah, the Earth orbits in a plane.
Okay, so then
the plane is not identical to the other planets in the solar system.
Okay, so then what I would
Damn, what's up?
Suspect then would be the case with the globe is if you have a globe tilted, and this is the sun.
I wasn't asking about the globe though.
No. I'm just.
God damn it! What is going on here?
I think it has to do with the vortex of the ether rotates, and so everything on that spoke, if you're closer in or further out from the center, you're going to keep that rotational heading because the whole apparatus is arcing in the same angular distance. It's covering the same whether you're in or out. And I do believe with the sunrise and sunset, that I could get on into the globe.
Right, let me re-ask the question, because you didn't really go to answering it. You said that the sun moves in and out through the seasons, and that's what causes the seasons. So what causes the sun to change the radius of its circles above flat Earth?
So I do believe the sun was made with a path set in mind. It could be an interaction as far as like the phenomena of what's pushing and pulling the sun in and out. It could have to do with the positions of
okay. That's good. I don't need a whole bunch of what ifs. Okay. Right? If you don't have an actual empirically verified answer, then just say that. And
cool. Since you want empirically verified answers, I want to know, how do you know what the sun is made of, how far away it is, how big it is, what the stars are, what medium they're in, and how you can have an air pressure system without containment. Okay. Let's get to that. Let's quit looking at fucking shit in the sky, for crying out loud.
And then then the audience can say, okay, well, it's just faith.
Yeah. And that it would be, I think it could have something to do with the charge, how far away it is.
Just guesses. It's just,
it is, but again,
it could be this.
It's this.
Which is basically all you've got, Mick.
That is something that I do admit that the sky is a frontier to us, unlike the Earth. Yeah, but it is something that I think is.
So you have to understand what's going on. Neither one of them has any idea what the fucking shit in the sky is. Well, MCToon going to pretend that he does know, right? Whereas he just said, oh, well, it's just a bunch of what ifs, which is exactly what astrophysics is, man. It's a bunch of fucking what ifs. All right. So this is very telling.
I have hypotheses and speculation. I think using a bike tire as an analogy, the sun is staying within the vortex, and if you put an object in a fluid and you rotate the fluid, it's going to keep that heading. Yeah, I would probably
got these snorkels
with something like that.
Snorkels up here, man.
Could I sorry, that might not be a sufficient answer, but I will initially off the bat, I'll claim that the sky is a lot less substantiated from my understanding. Do you mind if I ask a question?
All right, well, just if I could just wrap it.
Yeah, go for it. Respond. Yeah.
You in the beginning of your presentation, you talked about falsification, and so you don't even have a falsifiable guess as to what it could be. So that's not science. That's not scientific.
Right.
That's not empirical. It really is just a faith.
Would you
Okay.
equate the ether to, this is not my question, but playing off of that?
See, Nathan, you stepping right into the fucking shit right off the bat, man. Okay, what is this? You don't have to come up with all this. Okay? Yeah, it was bubbles in space, Daniel. It was we have snorkels up here, man. So you don't have to. You have to. This motherfucker here got to prove. He's got to prove what he says. He's got specifics, man. He's got a global Earth of a certain size, traveling at a certain speed. He has not successfully proven any of this. This is the claim that goes against observation. Flat Earth is not a claim. Flat Earth is an observation. Through actual scientific experiment and observation through those experiments, we can actually determine the true condition, which is obviously not a sphere, because it all requires some kind of fucking belief. So stop defending shit. You don't have to defend anything. He does. He's got to defend it, not you, Nathan. You're playing right into his hands.
Would you equate the ether, which is maybe not as substantiated as something like dropping a pen, would you substantiate that with space-time fabric? Because that also is not able to be quantified, is able to be manipulated or malleable or handled or measured. It is also mathematically conceptual. It's a framework.
Yeah, so the bending and warping and the properties of space-time have been empirically confirmed. The properties...
No, they have not. No, they have not been empirically confirmed, especially when we know that Eddington excluded data that did not go along with his hypothesis. It was just bullshit, man. Get out of here.
Of the hypothesized ether, which at one time, both of them were just hypotheses, but the hypothesized ether being specifically the luminiferous ether, or what Klinker-Fuse called the undulating theory of light, being the medium through which light travels. That particular definition of ether does not have any empirical evidence for it. But
I do agree that versions of ether can and have been falsified by empirical testing, but I do believe that there are ether frameworks that are able to account for.
Well, yeah, and so then when you change the definition of it and assign the name ether to it, it gets confusing because now the word is overloaded. You've got multiple things that both have the same name.
Well, if we approach it scientifically,
MCToon, Nathan, you let MCToon put you in defense. Wrong. Okay? It just goes right back to my analogy. If I claim that I can turn into a chicken, the burden of proof is on me because that's the positive claim, right? These clowns come out and say the Earth is a globe of a specific size and it's turning a certain speed and it's rotating around this star that happens to be a certain size and a certain distance. Okay, those are positive claims. When I look around me, I don't see any evidence of any such nonsense whatsoever. Nothing about my everyday life would make me believe that, or come to the conclusion that I was on a spinning ball, spiraling around, doing all this other crazy nonsense at all. Nothing in my observations or experiences tells me this at all. Okay, so against what I observe comes along these clowns with this positive claim that must be proven. And of course, if somebody had just laid this shit on you, you're going to have to answer some very specific and very basic questions like, well, then how do we stay on a ball? How do we stick to it? And of course, you're going to say gravity, and you're not going to be able to prove that nonsense. Okay? Not to a critical mind anyway. So you have to prove this size. You have to prove that there's this rotation. None of that has been done. You also have to demonstrate. Another question we would have is, how do we have air pressure without containment? Again, your go-to is going to be gravity, but you cannot demonstrate that air is affected by gravity or air pressure can be affected by gravity whatsoever. You've not demonstrated that at all because you haven't even proven gravity. So you got to stick to the basics. They have to defend their nonsense. Okay. You don't have to defend your observations. And there's no problem with saying what they say. Well, what do you think the sun is made of? I don't fucking know, man. I don't know. Okay. Well, we know that, and they always say we. No, you don't. A bunch of people agreed because they were all told by the same institution. Okay. That, oh, it's a ball of burning hydrogen. How the fuck did you get a ball of gas to form without a container? Come on, man. Basics. Come on, bastard.
Typically, we could discard those ether theories, like Feynman said. If it doesn't conform to the evidence, you throw it out. Yeah. So we can throw out that ether and then form a new ether framework, and then try to explain based on our updated observational gatherings, our updated understanding of how phenomena are, the variables, the conditions that can cause things to be.
So all of that needs to be done, though, right?
Yes.
There are just kind of some ideas. There are some vague ideas and some less vague ideas.
Yeah, well, I will.
I've not seen
back
confirmation.
If it's like if it came to where I had to really make a stand, I would still claim that what goes on up in the sky, if the whole sky turned purple, that doesn't mean that the grass is purple. What goes on in the sky is secondary to the primary of the ground, of geomorphology, the shape of the topography, so that said, actually, because one of the other things, and we've been talking a little bit about the sky and the shape of the earth and everything, and observations along water. But one of the other distinguishing mutually exclusive claims of a globe versus a flat earth or still earth is the motion itself. And so I'm curious, because the globe does claim that the only absolute motion, I could have a couple questions off this, but I wanted to just run something by you to see what you think about it. The globe claims that the rotation is absolute, and then you have the orbit of the sun, the galactic orbit, and then the orbit or the drift of the galaxy as it exploded from the Big Bang. Those are all relative motions because of the space-time fabric. So I am.
Well, that would be ridiculous in the first place. Okay, so when do the particles of an explosion, X meaning outward, ever meet again? They all radiate away from the epicenter of the explosion, right? So if they're all radiating from the epicenter of this explosion, how in the fuck could they possibly ever come together? Do you see how dumb this is? Right from its inception.
I'm curious, the Earth moving would supply a force. And actually, if I could share my screen real quick here, this here.
Yeah, you're up and running now.
Awesome. So this here, I don't know. Oh, I can zoom in. Yeah. Oh, whoops. Hold on one sec. So this. Zoom in
for you if you like.
This here is a diagram that shows it's the gravitational force, centrifugal force, and the effective weight. So even so, and I haven't done it myself, but people have said that they've measured is if you go to the pole, an object weighs more because you have these double compounding. The full effective weight is going all the way down to match gravity. If you go to the equator, you get a counter. The centrifugal force and the effective weight are kind of going at it with each other, so it makes an appearance of a lighter object at the equator. And if you'll notice, all these red lines they're all going straight to the center of the Earth. Gravity goes straight down. So what you get here in this 45-degree area is the greatest amount of centrifugal force. And so this actually would equate to something that is like a tugging, that it would pull us towards the equator. And what I was told is it would be about the weight of like a tomato of pressure. Like if you set a tomato on your arm, you would feel it. And then if you move it to another part of your arm or wherever, you would feel it if it was resting there. So if you are looking south at the equator, the back of you is the one furthest away from the equator and is what is feeling that pulling. And say you look south deadlocked the whole of your life, it would be constant, so you would never notice a change. But if you turn in any direction, you do not feel any sort of change of where that tomato would be on your arm. You don't feel a change in the further away from the equator side of your body. You don't feel that change being applied to that new area. And so I'm curious what, like, when we drop an object, no matter if we're at the equator, at the pole, somewhere in the middle, doesn't an object go straight down without any sort of hugging influence to, maybe it's just not dropped high enough, but my understanding is things go down.
Okay, so yeah, a good question. You took it off the screen. Just I was going to say.
I'll put it back up. I'm sorry.
Yeah, put it up. So what you do is you sum
There you
the
go.
vectors. Vectors sum. So
just wait. I'm still waiting to see your screen there. There you go.
At that middle one, which would be about 45 degrees north latitude where we live, you can see you've got the downward vector of gravity. You've got the sideways direction of centrifugal force. It's not straight up when you're not at the equator. At the equator, it's straight up. Everywhere else, it's slightly modified. But you sum those vectors, and that's what that is. That the blue, I think.
Purple.
Yes, purple. Okay, so that's the sum. That's all we feel is the sum of those. So, all right, you can take that off the screen for a second.
So, okay, well, hold on. So you said we feel the sum. So this here, the sum is off tangent from straight down where gravity is. So we do measure things falling off from straight down.
Yeah, all that we get is the total, the summed forces together. So, all right, if whoever played the game Descent, it's a first-person shooter in space. You're in a spaceship. It's pretty old. It's way too old for me to have ever played, being just 13. But rumor has it that people have played it. In that game and other first-person shooters of the era, some of them had a quirk where if you move straight forward, you move at speed, say, 1. And if you move sideways, you move at speed 1. But if you move forward and sideways at the same time, you move diagonal at the speed what?
1 squared plus 1 squared equals c squared.
Square root of 2. Square root of 2. 1.4. Okay. So you actually go faster if you do both at the same time because it sums them. Now, future games fixed that problem, but people that were really good at it would use that to go faster than you could normally go.
For speed runs.
Or if you're doing first person, PvP.
It's better to move quicker.
Yeah. But you're looking sideways when you're doing that. So you have to get good at it. You need to know the map, things like that. But people they exploited that. So that's what happens when you sum vectors. So we got that.
So he's actually disproved himself. If you think about what he said, he disproved himself.
So we have that vector slightly
so there's a skew.
Yes. So, but the quantity is very small. So at 45 degrees north,
Let's
take
go for guys. Let's go for
cosine.
You guys are doing good. That's great.
Cosine of the latitude, I think, is how much you get from that. But because of where we are and the angles there. So I'll show you. And you're exactly on. You're right here. And so I have this gravity challenge that I did, and the point of the gravity challenge is to predict the downward acceleration, not gravity, the downward acceleration better than gravity. So it's $10,000. I have money in escrow. I have it all written out here. I can't change the rules. There's even a checksum there. So if I vary the rules, you'll know. So, but the point is that there's a method. I described the method for the globe, and it's not the ideal method for the globe. But I'll show you the method that I use. Use the law of gravitational attraction. I use the second law of motion. I use centrifugal force there. Or sorry, this is not centrifugal force. This is.
But the problem is we've already got reification by having the the force for gravity be of a globe. I mean, you don't really have any verification of that.
Essentially, the gravitational field strength, and then this is centrifugal force. So in my challenge, I did not sum the vectors the right way. I did that on purpose. It makes it easier for flat Earth. Actually, it's actually easier math too.
Why does it make it easier for flat Earth?
Because because it's not as precise as it would be, as it can be. But in order to be as precise as possible for the globe, then the math is more complicated. And I thought, I'm going to keep this as much as possible to freshman high school level math.
And things that favor. So are you just you're someone who would say, hey, if I'm going to offer a challenge to the opposition, you want to try to favor the opposition as much as possible, give them as much slack to try to.
See, this goofball sits there and plays. He's not paying attention to the fucking show. Okay, this Ryan dude, he's not paying attention to the fucking show. How long did that stay up there, all fucked up in 4 different pieces, before this dude finally noticed it? He's more concerned about chatting with his buddies or whatever else. You can't if you're running something like this, man. You got to, or at least you got to be monitoring the show. Okay.
You know, rise up to the challenge.
Walk away for 1
Yeah.
second. You guys are all, what's going on here?
Okay.
Where have we gotten to?
We good.
Okay, good.
So, all right. So I'll run through this really quick. So yes, the downward acceleration is higher at the equator, or sorry, at the poles, and lower at the equator. So here's let's see what I use. Yeah, Fortaleza, Brazil is the one I used here. It's close to the equator.
Are you asking for a downward measurement? You're asking for measuring the rate
the
of
measurements have been done, and I have documentation of where the measurements
and
are.
those measurements are straight down.
The direction is unspecified. It's just the magnitude.
So is there any way can we measure or detect the tomato pressure tug towards the equator on an object?
There are ways to measure the deflection of the downward acceleration at different latitudes. It's very precise.
Hello, Fabio.
And it requires looking outside the Earth.
Whoa.
You have to use an external. You have to use an external
Quit doing that.
reference.
That seems difficult because we're talking about the Earth. So you would have to like do that from space.
Now, see, I'd be asking him where he got this R at. Okay. Where did you get this R and how did you get the fucking mass? How do you know you don't know anything about any of that? Again, all fucking guesses.
No, you have to do it from Earth, looking to something.
Hey, Ironton Auditor, good to see you, brother.
Star.
So hold on. So looking
Okay.
at the star is used to determine gravity?
No, you were asking specifically. You were asking specifically how could you determine the offset of the downward vector on the surface of the Earth relative to the true tangent at that location, and that's what I'm talking about. So that requires, this is outside of any of the stuff that's in this challenge, but that requires looking at an external reference. Which
see, and this is another thing that with this whole thing of it spinning. I was talking to a buddy of mine earlier, and I says, okay, let's consider a northbound flight. Let's say it takes off near it, right at the equator, and it heads north. Okay, it's going to New York. Okay, New York's dead nuts north of it. Okay, so it takes off. It's already got a sidereal speed, the speed going sideways. It's going roughly 1,000 miles an hour while traveling forward. So it's doing this. But the Earth, the speed of rotation, even though it's still only 1 RPM, as you get closer to the center of rotation, that speed decreases exponentially. So how is the plane compensating being able to go east in order to not overshoot its target going west? Right? It would have to be continually compensating for that and then match it. That's exactly what it have to be doing that at all times. And if you want to see what that's like, all you have to do is at a playground somewhere, if they still have them, I don't know. They make kids dress in bubble wrap now, but if there's a merry-go-round, get on it, going slow. Just give it one little push with your legs so it's rotating. You're standing on the edge. Now, try to walk to the center and see what happens. You're going to fall over like a drunken fool. You really will. So that's a big problem with this shit. Also, going one direction versus the other. I'm sorry, man. Have you ever been on one of those walkways, those automated walkways like at the airport, right? If you walk in the direction that it's going, you can really carry the mail. You can really carry the mail, man. But if you turn around and try to walk back the other way, you're being drawn back as you're trying to go forward. Same thing. You'd have the same thing. The equivalency principle doesn't work, man.
We can't just sit on the Earth and not have it. Just look internally. We don't know. You have to look externally to do that. So
are you dropping to get those kinds of precise measurements? You're dropping an object and seeing it fall down, and then you're comparing it to how it drops, like with respect to a stellar object.
No. Okay. The amount of deviation
last
that
word
you're
there,
talking about
MCToon, before we go.
What's that?
I said
It's very
last
small.
word for you before we go into the Q&A. Go ahead.
Okay. All right. Well, the measured downward acceleration in Fortaleza, Brazil is 9.7. That's the sum of all the vectors. And in International Falls, Minnesota, 9.8, slightly higher because we're at a higher latitude.
By
There you go.
0.02.
Well, in the screen
Do we
share.
get, Ryan, do we get closing?
Oh, you'll definitely get a closing.
By 0.02. Do you realize how insignificant that actually is based on the argument that's being presented? 0.02.
Don't worry there, Nathan. We'll definitely give you a closing. Or sorry, if you prefer to go by Pitchlumin.
You can, it's either. It's, you know,
Thanks
as
for
long as you're
tripping me
nice.
up, buddy.
Sometimes people are mean to me and I still respond. So
Oh, it's all good. Well, I appreciate you being here. I appreciate both of you. Our speakers have been awesome
it's been a pleasure.
this evening.
Really cool.
Honestly, this has been great to listen to. You know, when I have speakers on that are as great as you guys, it just gives me a chance to just interact with the live chat and fix things like MCToon is now back in our live chat.
I'm back. Thank you.
He's back, right? To make an Aerosmith reference. All right. So if you haven't already,
Get at him, y'all. Mike's there. Go talk to him. Ask him questions.
You know, these fellas didn't believe me that I do rock music. Yeah, you know, they don't believe that I like screaming at people for money. You know, it's like free therapy. All right, so we're gonna go into Q&A, everybody. If you haven't already, like I say, hit the like button, share this out in the spaces that you like having these types of discussions, which I know all of you like hanging out in those Facebook groups. I see you. Don't worry. I'm hanging out in there too because I gotta find all our lovely speakers. So let's get into the Q&A. Kango 44 for $20 says, question.
This guy, Kango 44, every fucking time.
For the flats, all of New Zealand is in daylight 3 hours before Sydney. Sydney is 2,225 kilometers from Wellington, NZ. NZ is 1,600 kilometers long. So why does sunlight take 3 extra hours to travel 625 kilometers? New Zealand? Sorry, I just said
no problem. So it could have something to do with if the light is going through a certain part of contour of the firmament, it would cause kind of a muffing of the ability of the light to travel, so it could slow it down for those portions. And then by the time that the light actually reaches Sydney, it would have gone past that part of slowing that the curvature of the firmament imparted on the lights. This again would be something set up by.
What time of year was it too? Was it during your winter when the North is having summer? That would have a lot to do with it. If it, you know, where was the sun's position? What time of year was it? What month was this? I don't know if they mentioned it, I didn't hear it. Did anybody hear him mention a month? Yeah, we got Terry in the house, little rat. You come barging in here.
An all-wise creator who has all the distances and everything, and that's what we observe, and then we measure, and then we build our model off of that. Yeah.
All right. Any thoughts on the other side there before we move on to the next question?
Yeah. What ifs aren't science. It's what is asserted without evidence is dismissed without evidence.
Yeah, that's why I would ask what time of year. Make that motherfucker spend another super chat to answer that time of year. You know, that matters completely. That's why in the North summer we experience longer days, and they experience shorter days in the South. Man, it's just, come on, y'all. Ryan, is that his name? What's his name? Pitchlumin? Dude, get on it, bro.
And I would to say to that, I would say the sky is not the primary when it comes to the ground shape. So.
All right, we'll move on from the old Hitchens slap, everybody. But if you haven't slapped the like button, give it a go. It will not displease you, I promise. PT Collins says, Nathan, assuming the Earth is stationary and the sun is moving above us, shouldn't we expect a more dramatic change in the sun's angular size?
That's it. So yeah, with perspective, when an object, especially along the ground, when it moves away from us, it goes through the speed changes of parallax. It'll start to appear to move slower. It'll appear to shrink. That is true. The object that we're looking at on the ground is close to us. It's out to 3 miles to the horizon. With perspective, when you look up, there's more visual data in one section of field of view. It covers a greater span, and that carries true all the way through the sky as it goes down to your horizon. So when you look up at things that are elevated, there is the apparent size and the apparent shape actually are less it takes much more for them to change. So the elevation actually helps keep the shape of the sun and the size of the sun, as well as things like water vapor being like magnification to help enlarge the sun as it goes away, and things like that to help it keep its appearance. There are variables in place to help it appear, which if we're considering an intelligent designer, that would be an intelligent design to make a sun that no matter where it's at can be the same size and the same parent view to help with the light properties and everything of the sun.
All right, thanks for wrapping that up. And just before you get into too much there, did you have any other thoughts on the other side? And I do see in the live chat, it's MCToon. Sorry about that earlier. I'm married to a Mick, so naturally.
I'll just go with Hitchens razor again.
Okay.
I'll go back with Earth over sky for determining Earth.
All right, let's carry on there, fellas. This is fun. And honestly, like I said, one of the most amicable discussions I think we've had on this in a long time. So big kudos to you guys. You made my life a breeze tonight. So especially after all I told you guys already, it's fine. Kango 44, Nathan, it is very easy to measure the shape of the Earth. Bob the science guy did it with total stations. You could do it in an afternoon.
Need an R value, G. Where'd you get the R value?
Kango's coming for you. What do you think?
Okay.
So apparently,
say we're going to measure the size of the Earth. Let's even throw it out to like Eratosthenes or these ancient Grecians who knew 2,500 years ago that the Earth was a sphere. If you're looking out to the horizon and you see a boat disappear bottom up, is the horizon at 3 miles away approximately or exactly? Is it 2.9 or 3.1 depending on refraction? Were they accounting for refraction? And then they take the 3 miles is 6 feet hidden. And so we can extrapolate that into a globe with a given circumference of 24,901 miles, or whatever unit of measurement they were using back then. How are you getting? Are you assuming your radius? Are you assuming the distance to the horizon, as opposed to having a firm fix? How are you making a measurement without having some sort of refraction put into the measurement?
Nathan.
You also have to have a known value for the distance and size of your lighting source as well. Okay. So Eratosthenes and his faithful assistant Theses, obviously using a Nokia brick phone so that they could communicate 500 miles with whoever was looking at the other shadow, assumed, first off, he went in with the assumption of the Earth being a sphere. He also brought in an assumption of light rays coming in parallel, which of course they do not. He also discounted the prospect of a close light source. So it had to be incredibly far away to support his presupposition that the Earth was a sphere.
Let's go this summer and make it happen. Let's measure it ourselves.
Let's measure it, big boy.
Come on.
Road trip.
Let's set an experiment.
No, we live near each other. We can do it.
I'd take a gun with me. What shape do flat earthers think the moon is, and how do they explain what we see? Okay, so what shape? It appears to be round. Okay, is it a sphere? I don't have any indication that it is a sphere, just because it can appear to be a sphere. I have to question its lighting for it to be a sphere. And the same face? Well, that is a good question. How do we see the same face? There's no degree of parallax to see the side of it or anything from people at different observation points on the Earth. So yeah, that's a problem for it being a big ball in the sky. It really is. It's a huge problem. Also, the fact that the ratios of shadows don't work out for eclipses. So that's another problem too.
Yeah. We'll go to a lake, set up elevations.
Oh,
come
come on, guys. Come to Nova Scotia.
We got to get a big body of water. We could go to, I don't know, how long across is Mille Lacs?
Mille Lacs is not calm. That's the problem. We need something that's got
tranquil water.
If it's got trees around, like Cedar Lake, north of Calhoun is a good one, maybe. I don't know.
Would that be long enough?
It's long enough. Yeah.
Bidem Makaska? Yeah. Oh, okay. But somewhere in the Isles?
Makaska.
Yeah. It's just,
I do apologize, Nathan. I'm sorry if I cut you off. Yeah, it's just that I
No.
have reviewed the questions. A lot of them are going to be, directed towards your arguments that you made tonight. So if I
fine.
inject just to try to get Mike in there, it's just, like I say, for the sake of engagement and trying to make sure that we have some things that can be addressed so that it's not like, too much gets put out there. before we
Damn,
get
I hit
into
the
it, right? So,
fucking thing.
The more questions, the
No, no,
better, as
because
far
we
as I'm
don't have
concerned.
access.
Whatever gets the truth, because if I might just interject here real quick, regardless of the shape of the Earth, whichever it is, I mean, there are people out there who, I know it's hard to believe for some, but there are people who are willing to harm others for their own gain. And so if the Earth is a globe, all religions are false. We can stop religious wars and everything because they all claimed at one point a stationary centered Earth that would falsify all of them, the Bible included. Whereas if the Earth is planar, we expose lies of people who are trying to manipulate us, control us. And so either way works, and whatever gets us to the absolute truth can bring unity and can get people to at least agree on peace and not harming one another, then we at least can prevent the preventable things. So I'm fine with whatever questions that help us get to really where the potatoes of the argument or whatever. So I'm fine. And all questions, please, I encourage them. That's why I have a channel. I ask stuff, and I want to know too. I used to think the Earth is a globe. I loved astronomy, and now I want to know. I'd like to live on the same Earth as my loved ones. So.
Well, that's yeah. I was gonna say, I think I think that one was pretty directed. I don't know if you have any thoughts there, Mike, but I honestly feel like I might have a question once we wrap up, just because you sparked me there. So, any thoughts there, Mike?
Hey, you can hop in the Q&A too. Go for it. Ask. You're here. You got.
No, it's fine. It's fine. We'll save it. The audience can just sit there and smolder and wonder what was.
No one's gonna know Ryan's question. Ooh, all right. Fair enough. No, let's get. Yeah, anything's fine. Really, I encourage open dialogue, free speech. I'm huge on all that. So, and I think that's really like I love science. I love questions. I love questions. I love critical analysis, critical thinking, strengths and weaknesses of arguments. I think all that stuff is amazing. It allows us to innovate in science. So.
Well, not to inject again, but we have LJ here actually. So let's ask LJ's question because it's going to be for you, Mike. Has gravity ever been measured as force? When?
As force, directly as force. You measure
No, it's a pseudo force.
it. One way to measure it is with torsion bar, and that it's an indirect measurement, like most measurements.
So what they do is they have a thing. You ever go fishing, right? And they got those little spring scales that you can use, and it'll tell you how many pounds the fish is. Okay. So what he's talking about is the same fucking thing, and they just use a different measuring system is all. It's the exact same fucking thing. Everyone knows that weight is nothing more than the relative density of an object within a given medium. This is why fat people have to do physical therapy in water. Okay.
Because gravity is not technically a force, right?
That's a reference frame question. Within a reference frame, it exhibits itself as a force.
Is the torsion bar appealing to Newtonian mechanics of matter attraction?
It's just mass attracting mass. So there's no distinction between that because Einstein's field equations solve to Newton's law of gravitational attraction for the specific things that we have in our reference frame, which is low velocity and low mass.
Okay. So Einstein has to incorporate an explanation for low velocity, low mass objects.
Well, yeah. Einstein
built off of Newton was the claim.
Yeah, the Einstein's field equations include application of velocity and mass, where Newton does not. So Newton is a simplification.
Why does Toon have your camera, bro? I wouldn't let that motherfucker hold on to nothing, man.
Of Einstein. I mean, it didn't happen in that order, but
doesn't Einstein, isn't that force equals mass times acceleration? Isn't that velocity and mass?
That's not Einstein. No, Einstein field
equations.
equations.
Isn't that Newton?
Newton is F equals the Newton's law of gravitational attraction is force equals mass 1 times mass 2 times a constant, a gravitational constant, all that over the radius squared, the distance between the centers of mass squared. The F equals ma is the second law of motion, which is also attributed to Newton. So he gets a lot of credit for different things, but it's just the second law of motion.
All right. Seems like we're all in agreement there. We're all just kind of jiving along. If you're jiving along and you're enjoying the discussion, let's bring it up here. Like we're an old MC announcement. We got MCToon, so let's do it.
Ladies and gentlemen,
hit that like button. Yes, let's get ready to Q&A. Next one coming in. Kanga.
I'm sorry, I didn't stop and point out the contradictions within and the assumptions involved within his first law and shit, but I'm pretty well assuming most of you already, the Einstein bears, right? That most of you already have this figured out as this is the constant thing. You have to look at every one of their things. This law right here. Oh, and you look and it's like, well, there's a lot of assumptions in that fucking law that are not actual facts. So why is it a law? Here's some ridiculous shit.
Says, Nathan, please explain in detail a sunset. Ding. I figure that's what he meant.
Sunset. Yeah, so that would be the I think I kind of showed it in my slides. You have the sun moving away from you with perspective. You have different compound variables in the air that would alter the size of the sun to keep it.
It's real simple, man. It's not complicated. A sunset is no different than watching a plane go over you. It's near you, it gets further and further away. Even though it's maintaining the same altitude, it appears to you to be going down. It's not really going down. We already know this because, you know, I see them look like they're going down too, and there's no airport near here for a jet of that size. All right. So it's the same thing. It's going to, if you get given a large enough object and a long enough distance, you're going to see it go. And it's going to meld into the horizon. Now, it's very difficult with something that is as bright of an energy as the sun. Okay, because we've also got these other things that come into play, because as you change angle looking at the sun, we are looking through more and more of the medium, which is of course going to magnify the object. So that's going to make it difficult as well. So that whole thing about sunsets is just, that's a fool's concept to think, oh, it must be going over a ball. It's dumber and shit.
Constant, the shape of the sun to keep it constant. And as it moves down, it's going to appear to set behind the vanishing point. And once you are beyond, every elevation has a set vanishing point given the conditions. And so once you go behind that vanishing point, it's not going to be able to be seen. And then if you increase, you're going to push further back. This is why you can go to some.
Oh, your mic got covered up, Nathan. Your mic got covered somehow.
My mic is my, it's my laptop. Can you hear me?
Yeah, I can hear you. For some odd reason, all of a sudden it sounded like you put a cloth over your microphone. So can you repeat what you just
sorry
said?
about that. Yeah. Okay. So, so you have a vanishing point, a hard vanishing line that, given your elevation, you are going to have a certain amount of distance of ground you can see and of sky. And so anything that passes that is going to be cut off as it goes. And as the sun, for example, would go down, bottom up, it would enter into that line. And so that's why, for example, like in Dubai, there's a building where you can see the sunset at the base. And then if you go to the top, you can see the sunset again, because as you increase in elevation, that hard set vanishing line at the back of the perspective of what you're looking at is going to be pushed further out. So you can get more information compressed into that bottom half and the top half. And then and then you have the sun and sky, they're colliding, and then they're competing for visual. You can only resolve so much with your eyes. So they get into competition with very, very small things off in the distance, and they cancel out and create that vanishing point. And so the sun goes behind that and it sets or rises, depending on, which way it's coming from or going.
It's just like I tried to explain to Brenda how a 3-foot wave, 25 mile or a quarter of a mile away, can actually obstruct a 250-foot object or 25 miles away. Okay. And it's because of foreshortening. Right now, my thumb cannot cover my face, right? But look what happens. Look what happens. This is the same thing. Look, at my thumb is covering my entire fucking face, right? Okay. But is it really? No, it's not. Did my face go behind the curve of my thumb? Is that what happened?
All right. Any thoughts over there, Mike, or you want to carry on?
No, none of that is how things work. Those are just assertions and incorrect claims about how light works.
Last thoughts for you. 10 seconds there, Nathan.
Incorrect thoughts about how light works. Let's see. So I do think if you go up in elevation, you can see more ground, you can see more sky.
Now, that is a great example of parallax. I said it. That means I must take a bong hit. Okay. So that is a great observation because what you're doing is you're actually changing your angle of view. Okay. Which, as he stated before, gives you more of the ground and more, see where it's going to converge. So you can actually see, you'll see the horizon will increase with elevation, which it shouldn't. It should remain static by a certain point. If it were a ball, your horizon would drop actually below you after you got to a certain height. And it doesn't. It stays just slightly below eye level all the time, about where it is when you're standing on the fucking ground. Boom, right there. And that's not the actual horizon. The actual horizon would be right at, but as far as your eyes can resolve, it's just going to remain at that same level all the time.
And so there is something being pushed back to allow you to see further with both. So I think that those would be observed.
All right. Well, thank you so much. Let's carry on there, fellas. Yeah, you're right, Max. I should always moderate with the wrestling voice, but I don't. I used to do the impressions and all that.
No, I had
I've since
coffee. Hold
behaved
on.
myself. So
Your ticket pays for the whole thing, but you only need the edge of your seat.
That's right. That's right. All right. So free Palestine. You know, if somebody asks for Jordan Peterson, I'll do it. I swear, I'm in that mood. Why? All right. So free Palestine says why there's no polar stars at the south and only polar stars at the north. Answer: Earth is seriously flat and stars are not light years ago. Stars are underwater. Check out Star in a Jar Experience. Sonoluminance. I feel like I should have read that with a Jordan Peterson voice because the
sonoluminescence. It's this thing hooked on phonics. It worked for me. Okay. I'm just going to say that. Sonoluminescence.
cadences in this was difficult. Go ahead. I think that one's for you.
All right. There is no star at the true center of rotation in the north or the south. Polaris is about half a degree away from the center of rotation. So the premise of the question is false to begin with. Then the rest is just claims without evidence. The distances to stars have been empirically measured. Not the time to go over those now, but they've been measured. And if you want, you could.
How were they measured, MCToon? Oh, that's right. They used the astronomical unit. That's right, MCToon. Where'd they get the astronomical unit, MCToon? Where'd they get that? How come it's changed from 3 million miles all the way up to an additional 90 million miles? And that's after going up to 100 million miles and then dropping back again. Okay. So where did they get these distances to the stars again? Astrometry. Yeah, you measured them. How the fuck did you measure them? That's a bunch of horse shit. Don't even try to float that crap.
You come on my channel. We'll talk about it. I think that's Earth is seriously flat. Is that you, Renee? Sonoluminescence is definitely not how stars work. How do
you know?
The Fraunhofer lines of stars confirm that there's a particular thing that's happening in physics to cause the light to be emitted.
Any thoughts there, Nathan, or do you want to carry on?
That was very
yeah. If
vague.
I could real quick share my screen here.
Oh yeah. We got a Sunny and share. Let's go for it.
Oh, I see
that
what
was
you did
too
there.
far. Too far.
I'm a dad. I get away with that. Go ahead, Nathan.
No, dad humor, dad jokes is the most elegant form of comedy, even over puns. It's the most elegant and refined source of comedy, in my opinion. So this here, to the claim of stars being different distances away, like what I had showed here is you can see how objects in the foreground actually move a lot quicker and cover a larger span of your field of view than more distant objects. So this here shows the hat in foreground. It moves very quick along the screen compared to the light back here it doesn't cover the full gambit of the screen. So more distant objects should, because we have observational parallax, a lot of times cosmology parallax gets put out to like the Earth on both sides of the sun, but the falsifying parallax to different claims of distance is the observational parallax. All objects in the sky, when we look at a time lapse, they move at 15 degrees per hour, regardless of where they are, how far away they are, or close, because some stars are claimed to be very close, some are very distant, but they all appear to move the same, which would be like if you were looking at a bunch of bat bags here, and they were all in the same line, they would all be moving at the same distance, whereas where we're not seeing something like a close star, like a Proxima Centauri.
Exactly, Tiffany. You won the internet tonight. The very fact that they have to defend it says that it's a house of cards. Vehemently defend it, not just defend it. Vehemently. tells it all.
Atari versus a very distant star or light in the sky moving at a different rate. They're all moving uniform, which would imply equal distance as opposed to variation of distance. Like we always, I've yet to see any parallax, anyone show any parallax that can refute close objects versus far objects, and having fast moving close objects, slow moving far objects. It happens all the time with our optics and with observations.
All right. Any other thoughts there, McToon?
Yeah, in 1839.
And if I'm not mistaken, Sapphire, Stuart was a Catholic. And the Catholic Church is what's pretty much, as we showed on our connection with the Jesuits, what is behind this whole fucking thing, man. It really is. So that says a lot. In fact, once he was deposed, they were trying to put, weren't they trying to put him back on the throne, or his son? Something that was that whole Jacobite revolution took place like 1750 something, or I don't know, in Scotland.
Friedrich Bessel measured the parallax of star 61 Cygni to be 0.314 arc seconds. The 6,000 about closest stars have been measured, have had their parallax measured with a couple exceptions. So it's been measured. If you want, I can send you citations. I've got on my website. If you just go there and search for stellar parallax, you'll find a long list.
Please, if you could send me those. I do ask though, is it parallax, like looking at the star from one side of the sun or the other, or is it talking about nighttime shit? Because this would be the parallax I was showing there with the screen share and with the revolution of the Earth over one night. That would be a nightly parallax that we would see every time.
Yeah.
Closest stars.
If the stars were close enough, but they're not.
But they are different. It's not a matter of it's not like after.
Wait a minute. If they were closer, but they're not, you're still reification of your fucking claim. It's, how do you know? Where are you getting this information from? You need more detail on this. And it's going to come right down to that initial astronomical unit. And when you look into that, you're going to find an assload of assumptions, man. Pure and utter assumption.
2 light years away, suddenly everything is far enough to appear uniform. There's a scale. So distant stars.
It's not 2 light years. It's the width of the orbit of the Earth.
So many Q&As there, guys. So many Q&As. Let's try to move on.
Biblical Earthers, I think that's a big one.
I think one way or another, no matter what we're talking about right now, we're gonna make it full circle before we get out of this Q&A.
Oh, like the stars.
Oh, you stop it. Yeah, you're trying to tap me. All right, let's see here. LJ. Oh yeah, a bunch of people did say they wanted Peterson. Oh my God. Okay, let me see if I can conjure this up. If the moon was physical and asteroids were real, we would have countless non-CGI videos from Earth of asteroids hitting the moon by now. Why don't we? At the end, I went too Kermit on it. So yeah, if the moon was physical and asteroids were real, we would have countless non-CGI videos from Earth asteroids hitting the moon by now. Why don't we? That's for you, Mike.
Oh, we do.
Yeah, and I actually, to Mike's answer, I don't know if you're done there, Mike, but I would like to say there was a video that I saw, I think it was from about a year ago, maybe a year and a half. It was an amateur astronomer, I believe, in Japan. It's called like a moon impact crater or a lunar impact, and someone actually caught a bit of like a light flare on the moon that was claimed to be an asteroid hitting the moon and puffing up dust high enough above the moon's surface to get illuminated by the sun. And then it settled down, but there are claims like that. But I think it might be plasma or something like that. But personally, for what I think, those kinds of things are
plasma. But
I haven't been there yet. Then if we were going to go,
thank you for supporting my answer.
Well, I want to throw out
what
I've observed, but I will say, like, if we're going off of what is empirically, have we ever measured moon rocks or tested what they're made of? If we're going off of the empirical measurements, the claim of moon rock is driftwood, so we're testing trees.
It's not driftwood. Don't straw man.
Well,
so, I looked for that guy, that physicist that says that, and everybody's seen that guy from 1965 saying that the moon is plasma and everything. And man, you can't find shit on that guy. You can't find shit on him anywhere. I've looked all over the place. You can't find it. But yeah, the petrified wood. he knows where he's going with that, because they presented Holland with moon rocks brought back, and when they were analyzed, they were found to be pieces of petrified wood. So what the fuck, man? India, McLuhan, India. Yeah. Right? Come on, you son of a bitch, play. Oh, stream ended 2 minutes ago.
There was a case of driftwood being.
You didn't look it up. Don't.
Wasn't it given to
claim.
the Dutch or the Prime Minister Holland or something?
You did not. All right. I'll explain it.
Send it to me. Please send it.
No. You brought it up. I think I deserve to explain what really happened.
Yeah.
So the claim was that the Apollo 11 astronauts gave a moon rock to one of the ambassadors for the Netherlands. The Apollo astronauts never gave any moon rocks out to anybody ever. The moon rocks were given out through diplomatic channels, and it wasn't in 1969. I think the first moon rocks to be given out were later than that. So the claim is that some Dutch ambassador has a moon rock, but it wasn't actually a moon rock. It was petrified wood, not driftwood. But there is actually no evidence to suggest that anybody.
Yeah, R. Forrester. You try to find anything on that guy, R. Forrester, and man, that's a rabbit hole. Oh man, definitely he's been scrubbed from the fucking interweb. I can guarantee you.
But he thought it was a moon rock, because the actual label that was in the display case.
Oh, come on.
So these things were found in a drawer, and then a display case was made from them. There's a little paper placard of some sort that says given to him, the ambassador, by the Apollo astronauts, but it doesn't say what it is. And then the moon rock was placed next to it. Not the moon rock, the petrified wood, which was in the guy's drawer.
This is getting
So some people made the connection that the petrified wood was what was given to them. That was never the claim.
It was a misplacement of the material.
It was a misunderstanding of what happened. There's a couple people that have done a full write-up. I have links on my website to them. If you search for probably the Netherlands on my website, you'll find it.
Okay.
Or
check out MCToon's website.
All right, let's carry on to the next question. I put up a silly little poll there, so if you want to vote on that, that's fun. Let's carry on there. Ooh, my mouse is doing some strange things. All right, so let's see here. LJ, having a degree only proves you can memorize books. That's a bit more of a statement.
Not always.
I don't know if that warrants too much here, because we have so much, LJ, to respond to, but you had your huzzah. You catty. All right, let's carry on. I love you, LJ.
Hey, we're actually real quick, if I might add this to that, because
go ahead.
With I was on a debate recently with somebody. There are many people who have degrees, who work very hard, who report on honest data, who are very intelligent, very wise, very nice people, and they do good work. There are a lot of degrees. Going to school for medical or for trade or anything like that, those are helpful to society. So I've had some issues with the school system myself, but there are definitely positives to being educated, having a literate public, so that we can read and discern things for ourselves and communicate with each other. I think it's very important.
So be learned. By all means, be learned. Don't be educated. I was once educated. I got better. Educated is indoctrinated. Okay. Learned is something completely different.
So, anyway, thanks for the soapbox.
No problem. You know what? I did up that poll, but I have to say, honestly, you guys have set a new bar for engagement. We've got lots of Q&A, and I think it's because you guys have made yourself so palatable for our live audience that they can't help it. They want to engage. So
Science is amazing. The discussion.
Kango44 says, Nathan, sunrise in Sydney, Australia is 3 hours after New Zealand is total daylight. New Zealand is 1,600 kilometers in length. Sydney is around 2,225 kilometers from Wellington, New Zealand. Why does the sunlight take an extra 3 hours to travel 625 kilometers?
Didn't you ask that already?
I think we read that one. It's the travel of the light. The dome might slow the light down as it travels the distance. So but the sky, not the ground. So again, I mean, the sky's purple, so the ground is. I play baseball. It's a round ball, a round bat, you round the bases, hit for a rounded average. Therefore, the field must be round. I think there's a misconnection.
No problem.
This is going to be 12 hours if we do this.
Yeah,
Kango paid
after the same
I squawk a lot. I gotta.
yeah. We've only got so much time here, everybody. So, and our speakers already, they were like, let's go for a long one, guys, because we're having fun. LJ, how were solar eclipses predicted pre-globe model? That's for you, Mike.
The Soros system, the Soros cycle, man. The ancient Babylonians.
For me, they were before the globe. The path of totality was not predicted before the globe.
Bullshit.
All that they had before the globe was identified patterns in the day that they were likely to happen, sorrow cycles.
Nobody is coming to see.
They did not know the time. They didn't know how much of it, whether it was annular or total. None of that was done, so they weren't doing much predicting based on. They weren't doing any predicting based on geometry. But now, the specific location of the eclipse is known years in.
They still use the Soros cycle to predict the eclipses today. It has nothing to do with a fucking globe.
Advance. The one in April coming up, the path of totality is known. It's known how much of the sun will be covered. It's a total eclipse. The amount of time that the sun will be eclipsed is known. All of these things are well known. It all uses the globe. It does not have any flat Earth geometry in its calculations.
And I would say to that, maybe if we're talking ancient times, there's no telephones or anything. It's harder to get information to travel distances. So maybe if you're observing an eclipse in India compared to England, people in India might have eclipse data from their viewpoint of the sky there, whereas England would have theirs. And so you might have a problem relaying information to be able to put together whole works.
But it's about predictions. They didn't.
So now we have the eclipses. Now we have the data. We have databases put together, and it's cycles. So you have cycles either going around the Earth.
Soros cycle goes back to fucking ancient Babylon, man. Come on.
Or above the Earth, but they're still cyclical. And if you have enough data points on the cycles, you can have the whole cycle.
This particular path is not based on a cycle. This particular path has never happened before, and it'll never happen again.
But you could see where, if eclipses happen at such a frequent.
Yeah, we ain't never had smiley face moons either. Got some weird shit happening, man.
So you can see where the moon will travel and whereby you can plot
their
cycles.
Know what time. Yeah, you don't know what time. You don't know the location. You don't know the totality. All that requires geometry.
All right, let's carry on. Free Palestine says the Analema is evidence of a local sun and Polaris. For you, MCToon.
And Polaris.
Sorry, MCToon. I've been warned.
So the Analema is hey, I have never seen any flat earther compute the consequences and then see that the output is Analema. How high is the sun? You don't know. How far away is the distance across flat earth? No flat earther knows. All of these things are necessary in order to relate the flat earth model, the geometry of flat earth, to the Analema. The Analema is a very specific claim about geometry. Now, the Analema is evidence for the earth being a globe, and that the orbit of the earth around the sun is slightly elliptical. That's what the Analema is evidence for.
So an earth on a slightly elliptical orbit at speeds of 67,000 miles an hour average would definitely be noticed and felt. Okay, so another made up bullshit. The Analema shows that there's tighter circuits in the north and they increase into the south. Okay, and then its path that comes on back and does it's all cyclical, man. It's all cyclical. If it were a globe, okay. See, this is the thing. We're 3 million miles away, further away from the sun during summer. What? That's ridiculous. I mean, think about that dumb shit. And so the Analema would be actually equal. It would actually be equal on both knots. Both knots would be equal. That's another problem we have, is with the amount of flora and fauna found at the corresponding degrees between north and south. We have high degrees of flora and fauna at the northern latitudes, but in the southern latitudes, at the same reciprocal latitude, we have very, very little in comparison. And when you get down far enough, there's nothing, you know? So there's problems with a lot of this. The shadow that eclipses the sun, not only true black hole in nature, is recognized as Rahu, the black sun. I've heard that. And we've run the ratios of shadows before. And according to like, all right, so this moon leaves a 70-mile shadow across the earth, then we reciprocate that and run the ratio. That means that the earth's shadow on the moon during a lunar eclipse would only be 10% the size of the fucking moon. So you'd see a little black circle go across the face of the moon. That would be all you'd be able to see. But no, shadow spreads out in that instance, but doesn't in the other. I mean, it's just ridiculous shit.
And somehow Polaris, I don't know why Polaris was in there, but Polaris is not in the dead center. It's about 1/2 degree off, and it measures to change in location annually.
Before you respond, Nathan, I want to check with Mike. I'm cool to keep this going as long as you guys want it to go. You know, you guys are super cool.
But we've got to end it. We can't just go indefinitely, though.
Okay, cool. I was gonna say I know how long you're willing to go now, Mike. You know, let's just leave it out of context. Don't put any context on that, and we'll just carry on with our live chat. You know,
we'll let them field a couple more questions, and I'm going to just cut out of this thing because we've been up here 3 hours, and I don't know. Well, let's just see what happens here.
As a dad, I make some inappropriate jokes here and there. It's fine. Jesse Bergs says, a while ago, Kobe Cotton of the Dude Perfect group went up to out of space. And on the video, we can see that 1, he floats freely. 2, we can see clearly from the window of the capsule a rounded Earth.
Yeah, this one's for me to answer, right?
I think so.
Yeah, boy. See, I was going to try to put this into my slide, but I couldn't really fit it on there. I was going to throw it in with flights, with the airplanes and everything. But if I pull this up here, and then I guess exit that and then go here. And then if I share my screen and I clicked on this, is this, okay, now it's just about to pop up.
Shares. All right, let me just make our faces a little smaller so that we can see your diagram. Oh my, our faces.
Is this on this? This is on the screen?
Yeah, I'm just trying to make our faces a little smaller.
Bunch of like
can see it.
Curved rectangles or something. So this here actually is a diagram of a plane window, but these and I don't know if it has to do with making them more having more structural integrity, having a stronger, a more toughness. But window panes on flight craft are curved. They're actually physically curved, which can cause the effect of seeing what appears to be curvature. But if you look at the Red Bull jump, which I actually think I have here, you can see that you also have you can see that you get the planar. You have.
I think I showed that to somebody on an airplane one time. They were like, "You can see the curve of the Earth." I says, "You want to see something really cool? Step back here." We stepped out into the aisle. I says, "Now look through all the windows at the same time." He went, "Oh." I says, "So the Earth is daisy shaped, isn't it?"
Well, you have a flat horizon. You have weather balloons that can go 120,000 feet in the air, and they reveal a planar flat horizon. Even
Can you send me one, Nathan? One with a non-fisheye lens. Can you send me one at 120,000 feet with a non-fisheye lens, non-GoPro?
Well, yeah, I will. I'll send you what I got. But I will say too.
Don't go off there because I've seen them. I've seen them all. All the ones that show a flat are GoPro lenses, and they're cherry picked just a couple seconds or a minute or 30 seconds, whatever, where it's at the correct angle to make it.
I've got a whole video of a balloon at 120,000 feet that's going for quite a number of minutes. No turbulence, nothing. Just sitting there, watching the clouds go. So this guy, this is what he needs to bring up. The fact that the horizon would physically drop, and there are demonstrations of this, several. I have several. Okay, the horizon would drop. So I don't even want to hear your bullshit about that. We've seen the picture that we've seen the lenses that they use on the supposed ISS and high altitude, and they are extreme fisheye lenses. That's the only way you're going to get any curvature. Okay, you get curvature on the ground as well. But the thing you have to understand is as you rise in elevation, you would end up with the horizon dropping beneath you. It would drop below you. You would come to a point where the horizon would drop below you. You would have to look over to see it. But we don't observe that at any time.
Sort of look a little flat. Typically, the edges are curved up, making it look concave. Find one. Find one with a rectilinear lens where we know the properties of the lens.
Okay. Yeah, I will.
I dare you.
I'll find what I got because I will say like the
I dare you. I dare you. A little fucking lesbian.
the dog cam video that goes up. You can it'll as the camera wobbles and oscillates and everything. You will get the horizon to appear.
Yeah.
In various
not the right
angles
one
and
to use.
slants,
Yeah, that's a GoPro.
but they don't convex and concave, and then if you're flat at the middle,
Sure
you
they
can
do.
see level at different tilts and angles.
Yeah.
No matter which way it's oriented.
Yeah. So I don't know why you'd want to use a fisheye lens. Use a rectilinear lens instead.
But a fisheye lens curves the further away you go from the center of the lens.
And it curves opposite directions, above the center frame and below the center frame.
Yep.
But that
And
dot
right
cam
and
shows
left,
no curve,
anywhere
whether
of
the
center
horizon
frame.
appears lower than center or
Yes,
above
it
the center.
does.
It appears.
It's because of the convexity of the lens. They do that in order to get a wide angle. Okay, you can go up with one that's got a rectilinear lens, and you're still going to get the flat horizon. Sorry, man. You know, if your curvature is that claim that you're seeing, then what's your claim for this? What's your claim for the inversion of it? You just blew it on yourself. When the camera is at rest and setting there, it will show a horizon. Okay. And a GoPro, yes, is extremely distorted. Extremely. Because even toward the edges of it, you'll get distortion. So that's not necessary. All it takes is video, and it can be done. It has been done. MCToon's talking out of his ass again.
Plain, it appears straight, especially not the curve level of a fisheye.
It does not. It's not a fisheye. Fisheye is what a lot of flat earthers say for GoPro.
A barrel distorting lens.
Barrel distortion. Yeah. Yep. Find one that's not a GoPro. Find one that doesn't have strong barrel distortion.
I hope I came in at a good time, guys. You sound like you're right at the end of a thought.
Yeah,
And
You should.
it's all good. I just had to check on my son. He was calling for some water. So, Dad, to the rescue. Let's carry
Yes,
on.
sir.
Yeah, I was just saying.
That's always got to make time.
Well, yeah.
Dad's got to do.
Not 9 and a 6-year-old, right? You know, it's one of those things that every once in a while you hear in the background. You're like, aren't you supposed to be sleeping? I'm in Nova Scotia, everybody. It's 12 o'clock right now. If those kids are asleep, I don't know what I'm supposed to do.
Those 2-hour late starts nice.
Let's carry on, guys. Oh my goodness, there's so many super chats. We might have to set a timer. If Mike, you have an intention of getting out here in good time, let's set a 2-minute timer for these questions because
that's a good idea.
We'll be here all night if we don't do something else.
All
right. So,
half.
Jassy Bird says a while ago, Kobe Cotton of the Dude Perfect group. Oh yeah, we already went. Jassy Bergs says again, lengths of train tracks in southern places are much shorter than what it would have been to be on a flat Earth. Why ignore the clear evidence for a globe? We'll set 2 minutes.
So yeah, I think the distances over land, I think we can measure pretty well because they're over land. We know if we're laying a 10-meter section of track, it's going to be 10 meters. As far as the contour of the land, if it slopes at all, if you're trying to go around a turn or anything, it could change the straight line distance to distance, actual distance. Like if you go straight over something versus having to take a hill, it's going to appear longer if you take the hill. But I do think we can know distances over land pretty accurately as far as the spacing between them over like southern oceans and everything. I mean, even a few years ago, there were problems with flights disappearing and stuff. So maybe the continents have their shape, but also too, the military does own the GPS and they don't give away a lot, like their most accurate data for reasons, defensive purposes, to not have direct pinpoint location of any craft or anything.
This thing.
But they withhold the most accurate maps, and the UN, the International Civil Aviation Organization, the USGS, and all these, they all use a flat Earth logo for whatever reason as their logo. They don't use like one of those bendy globe things that looks like a letter M or anything. So I think we can accurately know. And then I showed in my slide in the bottom corner of the slides, I showed a map of the United States. It's like one of those things you would fold out in your car. It's a flat map on a flat piece of paper, has a key, has scale. You can travel with it. It shows rivers, it shows roads, it shows highways, it shows cities.
That's
all that stuff.
there, Nathan. So we'll give Mike a chance to respond to some of what you said.
The very specific question was about distances over surfaces, which you said was primary.
Yeah. So we're using nautical miles over the oceans, which is based on stellar observations, and then using statute miles over land. Okay. All right. Yeah. No room for error there.
Not secondary, tertiary, primary. And so the distances of things like train.
God damn it.
Train
I'm not
tracks
gonna put
are
it
well known
on.
across Australia. You talked about it with PhD Tony. Match the predicted distance when you compute the consequences of the globe. Matches when you compute the consequences of flat Earth. They don't match. That's science. Flat Earth falsified, unless you have a different way to compute distances between points on flat Earth but no flat Earther has ever presented that.
That is time.
We've done the polar distance formula for you, but you don't like it.
So I would say to that
Sorry,
that
Last word.
we can make a map of maybe a local area like Australia and have a map, and we might not have it laid out as far as resolution and everything to try to put it to an entirety flat Earth map. But there are no accurate globe maps or anything either. So
yeah, there are.
No, there's not.
There's definitely accurate.
No, they're not. No, they're not. No, they're not. Don't even try to present that fucking Mercator bullshit, man.
Accurate globe maps.
Well, you'll get a chance to expound on
coastline
that.
paradox.
In just 1 second, you just wait before you trigger every.
No, we can wrap that.
You're good.
My
All right,
fault, yeah.
Leo Crow says, over to you, MCToon. I gotta get used to saying that too, just so I behave myself. What evidence do you have for the sun actually operates by nuclear fusion? This has never been proven in human history and is impossible if indeed maintains an axial rotation.
Neutrinos.
2 minutes on the clock.
Non sequitur for why it would be impossible, but has it been substantiated?
I can tell you why it would be impossible. First off, this hydrogen had to form into a mass. Gases will not form into a mass in a vacuum or any other condition, okay? Because as we've discussed before, the gas particles are not bonded together. It's, wow, okay? So first we have to have this mass of hydrogen somehow miraculously form into a gob in space and then become the source of its own fucking pressure to the point that it's the source of its own fucking pressure, and it gets it to the point where, and this is all based on this nonsense of fucking gravity, you get it, right? And so that pulled in so bad because it was so much and so huge that it burst into nuclear fusion and shit. And it's like, wait a second, how did you get a ball of gas in the first place, man? How did you get that? Show me a ball of gas any fucking where. Go ahead. You can't do it, not without containment. So don't even start. Oh, we know it's this, that, and the other. You don't know jack shit. Shut up. That's all made up bullshit.
That's a good question. Not super familiar with the details of it. One of the things that is done is spectroscopy to know the particular makeup of it, and knowing the distance and the angular size, we know the linear diameter of it. That gives us the ability to determine the mass of it.
Wait. How do you know the linear diameter of it? Ask him, kid. Come on, pitch. Ask him. How do you know the fucking diameter of it? Where'd you get all this from? I mean, Christ, we had one guy say it was 3 million miles away. And then over the course of that time period, we've come up to, went to 103 million miles. And then they had to drop it back to 93 million miles. So they went up higher than 20 million more than it is now. And then back again to 93 million. And that's where they're going to play at. You know, and why so many vastly different fucking measurements? You can't tell me that your methods of measurement got better or something. That's stupid.
And what happens in the center of it. So these things are, of course, yes, we nobody went there, nobody scooped out a bucket of it to test what it was. You have to, just like basically every single measurement in science, every single thing in science, except for the very most elementary things, you have to do something other than just looking at it and grabbing it to see what it's made of or what it does or how big it is or any things like that. But melodic lyrics is a good point. Fusion gives off.
So we're just going to look at a rainbow and then say, hey, this is what we think that means. You know, why don't you just toss fucking chicken bones in the corner, you know?
Often neutrinos, and we do measure them. So there you go.
All right.
And I do think like the globe would have to explain what a star is and try. Nuclear fusion is a part of the cosmic evolution of the universe with stars fusing light elements into heavier elements up to iron, and then they go supernova or red giant, and then they explode and become higher elements. So that would be the claim. It's the phenomena claim of what stars are to help allow for the idea and conception of a globe to be able to be not conflictory as far as
the theoretical claim. Don't forget that. Yes, like guess. That's right. They're getting better at guessing.
How we get these higher elements and everything from
Right,
the Big
Brenda?
Bang producing helium, hydrogen, and lithium. But yeah, it's the model. But yeah, and I would question.
Back to my very first part of my presentation, the flat Earth has nothing. You need to compute the consequences for your claim and then see what the sun is. If you're claiming that the sun is
No. You have to actually prove your claim. Okay. We don't have to come up with an alternative to it because you haven't established any facts. That's the reality of it. Okay. You have not established any facts. You put out hypothetical, theoretical fucking bullshit and claim it as though it's a fact, unless somebody comes up with something else. Well, first off, you don't get to, you can think that all you want, but it doesn't mean that it's true. I don't know where these people get this. It's, I guess, truth through consensus.
Local and small, then it's on you.
You know, I think I figured it out. That's why these people are so fucking worried. They think that truth is dictated by the consensus, which everyone knows that it's not, because truth is truth in a minority of one. So I think that's a big realization. It's so simple. Very, very simple. We'll go through a couple more questions here and then we're going to cut out. So we'll see what happens. But man, oh man, this guy just, why is Nathan not, that's the kid's name, right? Why is he not saying, wait a minute. What the fuck do you mean that I don't know what the fuck it is. That means that what you say it is right. That's what he's basically doing here. Oh man, dude, come on, man. Why is this fucking shit doing this?
To provide the evidence for that. So asking me for evidence when you don't have it, hypocrisy.
I think a sunspot.
Wait, no, you're the one with the positive claim, jackass. That requires the explanation. All right, that's why I don't know what the fucking sun is. All right, you claim that it's 836,000 miles in diameter and that it's 93 million miles away. Prove that fucking shit. Don't tell me you shot radar at it, because we already know that's bullshit too.
Local sunspot. Okay.
Oh, okay. Yeah. I was going to say, actually, you know what? It's good that you wrapped it up there because that was for Toon. Mr. E-Man, can the flat earther explain the change in the length of day throughout the year?
Yeah, so the sun on flat Earth model, the claim would be that the sun is making this a small circle in the northern hemisphere, and then
Gerbil got to scratching really hard,
or inner circle on a flat Earth model, and then as you go further away, the sun moves away from you, and it does increase its speed to keep its 15-degree-per-hour heading, and so you're getting a more distant sun, you're getting faster traveling sun. You're getting less direct sunlight because it's further away. It's lower in the sky typically, so you have more atmosphere, more thick atmosphere to cut through with the light. And so these things would all cause, the variance in days as the sun ebbs and flows, small and large, and back in the small circles again and again as it makes its solar cycles.
All right. Was that your last?
A lot of circles. That's good. I mean, I think if Mike's cool, I mean, if he wants to answer that or anything. Cool, but that seemed kind of like how would a flat Earth explain this, which I'm sure Mike might know about how the attempt of explaining day length is and everything. But again, too, like if you look at the crude example of that dome and everything, it shows similar.
Well, you can also think of it as an LP in that respect, that each one of those grooves appears to be a circle, but it's actually a big spiral. The whole thing is a big spiral, and is the sun's and the moon's path above us. But if you can imagine the stylus is moving and not the record. Okay, so the stylus is moving and it keeps playing between the same two tracks. Okay, and the in between of those is the equator. So it goes back over here and it keeps going back, it keeps going back, keeps going back, keeps going back, like that. So it's almost like concentric circles, but not quite, because it's a continuous spiral in order to achieve the circuit path that it does, like a coil.
Light pattern too.
See, Mike is back.
I have a response to that.
I was just about ready to ask my question just to push it along, but you know what? Save it for after this. Go ahead.
My response is quick.
And that coil is reflected in the Ouroboros, or the analemma, that is indicated by its path.
Hitchens razor. Over to you, Ryan.
No, let's carry on. Let's carry on. I thought you might be gone a little bit longer there, Mike, but you know,
what in the fuck is going on here with this? I don't get it. I got great internet.
That's all I have.
That's all I have.
I know what his answer is.
You're talking.
I didn't need to be here to hear it.
You're talking about your response, not the bathroom break, right? That's all you have. All right.
Yes.
Let's carry on. All right. Let's carry on. Let me scroll up. And I say scroll up because there's a lot of questions. I'm setting 2-minute timers, but you guys are just, going about 30 seconds over. So PhD Tony says, Tony, yeah, you were talking to him last time. Can Toon name a material, or maybe this isn't the same PhD Tony. Can Toon name a material capable of supporting its own weight over spans of thousands of kilometers? If no such material exists, how can a firmament exist?
Yeah, there is no known material. And I suppose if you were to compute the consequences of a firmament, a dome of some sort, that would have to be 12,000 kilometers, or 40,000 kilometers in diameter, and an unknown height. But it doesn't matter. Some tall height. The material behind that would be quite something, including that the claim is that there's water on the other side of it. So how would that happen? Well, that's a high bar. That which is asserted without evidence.
Why doesn't a bubble collapse?
Is dismissed without evidence.
Yeah, and I would say so. Like, I think the hardest object that we have is diamond. I know, like, hydroxyapatite on our teeth is pretty hard as well. But like, we have these hard substances, and so but we're able to break them if we want to, or if we do the right things, apply energy to them or anything like that. But if the creator, who's all powerful, all capable, makes an unbreakable material, because man cannot go into the heavens,
5 seconds.
then no one is going to get past that or be able to scratch it or test it or anything like that. Extract material to then be able to analyze.
Bringing God into this, boy.
Unbreakable. It's the firmament. It's the sky. It's a barrier.
Thoughts there, MC?
Don't you be bringing God into this, there, boy.
Hitchens razor.
Okay. Toby Walker coming in. Why do globers pretend that we perceive space in Euclidean and ignore the fact that train tracks cover in distance? Toby Walker says, to follow up on my previous question about train tracks, do parallel lines ever actually converge in reality?
No.
That's a great question. So parallel lines. So on flat Earth, you've got the flat Earth, which would be parallel.
Come on, man. I'm not going to put up with this much longer. Why am I not being able to play it? God damn it.
Flat Earth, which would be parallel to the plane that the sun is in. And so they do not converge in reality. So the sun could never set because they never do converge in reality. Thank you for that, Toby.
Because you're trying to apply, once again, two-dimensional orthographic geometry from a third-person perspective to that of the observer, which cannot be done. Oh my God, I'm so tired of listening to this fool. Let me just stop this now. Wow. No, that's the trick, man. That's the trick. These people do not understand perspective, not to save their fucking life. And in fact, if they do understand it, they're pretending that they don't. Because I can't understand how anybody could think that we see what, I don't know, man. I don't know. You have to do it from the perspective of the viewer. I'm sorry. That's the trick. We're going to go over that again tomorrow, I think. We really need to dive into this perspective aspect, the refraction aspect of it, and all of this really needs to be gone into. We're going to simplify it. We're going to show you how the trick is done. Okay, that's what we're going to have to do. Sorry. Just can't take any more fucking MCToon tonight. And I'm almost like I'm going, come on, kid, do this, do that, do this, do that. And I'm thinking, no, I think fucking MCToon's kicking his ass, man. And cheating at it, of course, because he knows that he can intimidate. I think this kid's intimidated by MCToon. I think he is. Not realizing what he's really all about. I just wish I could, I would have liked to, if I could be him for a second, jump into him and say, no, all right, there's your opportunity. Pew, grab that right there. He's leading you into defending your position, and your position is saying that what you got there, buddy, is bullshit. You need to prove that. Okay. And they hate that. They hate that because then they have to fall back on their science doesn't prove things, blah, 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 blah. Well, then how the fuck it's a globe, right? Come on, man. That's what you got to do with these guys. You don't get into, well, what if you don't know what it is, that means that what I've said must be true. No, it doesn't mean that at all. Okay. You can't just sit there with a bunch of fucking fairy tales in your head and think that that's how the reality of the world is. It's just not. I don't know, man. But you got to be careful. These guys are practiced at the art of wizardry in reversal. Okay, everything they do is reversal. And just like with the globe is all reversal. It's all inversion. So what they're trying to do is, what? You don't agree with my thing that disagrees with your observations? Well, prove that it disagrees with your observations. No, fuck you. Prove what you're saying. You're telling me a specific size ball with a specific rotational speed, with specific distances, speeds, elliptical orbits, and all this other fucking nonsense, and you can't prove any of it. You want me to just prove what you say? No. You have to prove what you've said. It ain't the other way around, because every intent and every bit of experience that anybody ever has is that of a stationary, except when we have an earthquake or some shit like that. But a motionless earth, man, still as hell. Go out and sit by the still pond. Enjoy the peace, right? There's no flying around at the speed of sound and all this other nonsense. Well, it's because you don't feel it because of math and all this other nonsense. No, man. No. Make them prove their claim. They can't prove their claim. If they could, they wouldn't have to resort to the trickery that they have to resort to. So just keep that in mind, everybody. We're going to come back tomorrow. We're going to talk about perspective. We are definitely going to talk about perspective. Maybe throw a little gravity in there, and we're going to actually show how the trick is done. We've got some more people that have joined us and maybe missed the show that we did a few months back on that. And we're going to pick back up on that and get into it a little more tomorrow night. So I want to thank everybody for showing up here tonight. Got a great crew here. Got a great crew. Love you guys. We've been doing pretty good here, man. We had up in the upper 80s of viewership all at one time. That's a pretty cool thing. So yeah, let's just get doing it. And like I said, we're always open for business. You can come up and hit the link and come on. Like I said, tomorrow we'll hit that perspective and we'll look at what things would look like on a globe and versus what they look like on a stationary level plane in reality. So until then, I want to let you know that the Lord loves a working man. Don't trust Whitey, and see your doctor and get rid of me. He'll probably kill you. We'll see you next time. Good night.